KP classes dedicated to excellence.
Okay, thank you all for the confirmation that it is clear. Let us begin with the session for today. So as you are aware, this will be a 10-day revision course, and in these 10 days, we will focus on revising the important concepts in each and every subject. And our focus will mainly be on solving questions from past gate. And secondly, our focus will be more towards numerical part because that's where there are a lot of conceptual things, and for sure we will also revise some theoretical concepts in particularly subjects where theory is more important. We'll have an emphasis on the theoretical part as well. So that's about it. Before I start with the session, let me tell you a couple of points. So like this 10, you might have seen the schedule also. This is a tentative schedule. We'll try to stick to this schedule to our best possible level, but then there is a possibility that there could be some minor changes. If there are any changes in the schedule, you will be informed prior itself about any changes as such. So uh, you might have joined a WhatsApp group too. There is now this is particularly for those students who are not already enrolled into any of the batch. As you are aware, this revision course is accessible to all our existing earlier students as well. Other than those earlier students who have already joined us, who are already preparing with us, other than those students, for those who have just joined the revision batch, you have a separate WhatsApp group. You might have already got a link of that in the notice board of your batch. If you have not yet joined it, join at the earliest so that you get the class link on daily basis to attend the sessions, to attend the live online sessions. That said, you will have access to all these sessions in a recorded form as well, so that you can recall if you miss any lecture or if you want to revise any topic later on, you can access the recorded lectures as well for your later on reference. And we'll be covering around 20 subjects in this revision course. Obviously, I let me give you the disclaimer also in the beginning itself. It is highly impractical to think that you will learn everything in these 30 hours. This is a 30-hour revision class, and it is a revision class. We'll cover all what is important, but there are some boundaries we need to draw because of the time constraint. So we'll be covering approximately around 20 subjects. You might have gone through the schedule as well. On an average, we'll be covering 2 subjects on daily basis. Like today, the lectures will be 3 hours long in general. Today, we'll be focusing on these 2 subjects, estimation and project management. Both are very important from numerical portion point of view, particularly in the common part. Both are common part subjects. So we'll cover these 2 topics in today's class and the upcoming classes. Tomorrow you don't have a class on the occasion of the Republic Day. Day after tomorrow you'll be having housing and environment and so on. You can go through the schedule. On an average, 2 subjects per day. That's what we are targeting. So let me and I hope you have seen the course introduction video as well for this first track batch. So you have an understanding of what we are going to expect here. Let me right away begin with today's subject. Today we'll be looking into the subject of estimation and then project management. First, we will be covering this subject and then we'll be looking into the details of the subject of project management. Uh, to give you an understanding of these 2 subjects and their importance, first let me talk about this particular subject of estimation. Both, in fact, estimation and project management, both are in the common part, that is part A of the official syllabus. And like you are aware, in the GATE examination, 100% of the questions or the complete paper will not be in alignment with the official syllabus. There are always deviations which you see in the examination. The same has happened for these subjects also. Like for example, 2024, the year before the last year's paper, there was a question from of the subject of estimation in the architecture part. Even though it is in the subject falls in the common part, a numerical question on estimation was asked in the architecture part, and at the same time a numerical from the subject of structures on the calculation of bending moment. Basically that is in the architecture part officially as per the official syllabus, but a numerical on that was asked in the common part. So those deviations happen. You see such minor deviations in every paper, but as per the official syllabus it is common part, and mostly you'll get the questions in the common part only from this particular, for both these subjects of estimation and project management. As far as the weightage, before I even talk about weightage, you can remember in last 5 years, or in fact even before that also, even few couple of years before that too, there has not been a single gate paper where you don't have a numerical question from the subject of estimation and also from subject of project management. You get a new, not only that you get a question, it will be a numerical question in most of the instances. So remember that it is important from numerical portion point of view. As far as the weightage is considered for the subject of estimation, in 2025 paper, this subject of estimation had a weightage of 4 marks. The year before that, it was 2 marks and that was a numerical. In the year 2023, the weightage was 4 marks again. In the year 2022 also, the weightage has been 4 marks. If you look into years before, I'm talking about estimation particularly here. In the year 2021, the weightage was 2 marks again. In the year 2020, the weightage was even more higher, that is 5 marks. So if you look into last, say, 6 years of papers, the weightage has ranged anywhere between, there is no question with 0 marks of weightage, but anywhere between 2 to 5 marks. So it is mostly most likely that, so you see number of times you have 4 marks of weightage is even more higher. So you can expect around 4 marks of question from the subject of estimation. And I hope you know the importance of each single mark in the gate examination. Even 1 mark can take your rank forward by 100 ranks also. That's the level of concentration which the distribution of marks will have, particularly in so when you talk about, so if you leave the first, say, 10 or 15 ranks, after that the concentration of marks becomes even more concentrated. The number of people per for on a given mark will be even more higher. So with every mark you can move forward by 100 ranks also. So it is very crucial to not to capitalize on each and every mark you can score in the examination. That's the weightage of estimation subject. As far as the subject of project management is considered, consistently for last, say, 3 years, every time it was 2 marks of weightage. In general also, if you look into last 6 years, every year the minimum weightage has been 2 marks and it is mostly a numerical question. There have been instances of higher weightage also, like 2022 the weightage was 4 marks. So if you look into the weightage of this subject of project management, last year the weightage of it was 2 marks, it was a numerical question. In the year 2024, again the weightage was 2 marks, it was a numerical question. 2 marks numerical, 1 numerical, that is so in the common part itself. 2024 also it was 2 marks weightage. 2023 also the weightage was 2 marks, a numerical question. 2022 the weightage was 4 marks. There was one numerical and one theoretical question also on this subject. 2022 paper. 2021 the weightage was 2 marks again. 2020 the weightage was 2 marks again. On so you have numericals on float calculation, you have numericals on project completion time. Last year I think there was a question on crashing also. So there are questions based on the numerical concepts. In general, 2 marks of weightage is what you can expect from the subject of project management. So that's the now this is almost certain. Now gate exam can always be unpredictable. There can always be new unpredictable things in the exam, but something which is almost sure shot is that you will get a numerical from both these subjects, at least one numerical from each. uh, from the subject of estimation, there are instances where there are 3 numericals asked in a single gate paper. 3 numericals, that too from a single subject of estimation. So it can go even to a higher weightage of, say, 7 marks also. That has happened in the past. So they have asked, there was a question paper. If I'm not wrong, I think it is 2016 paper. There were 3 numerical questions from the subject of estimation only. So that also can happen. Don't think that you will get only one numerical from a given subject. So that's a brief introduction about these two topics. And the best part is both these subjects, particularly estimation, it is not that difficult to score. So the questions are relatively simpler, easy to score. So you can be confident. The only thing is two things. One, you should not do any silly, you should not have any silly calculation errors. You should avoid silly, particularly if I talk about this. So I will first talk about we'll first focus on the subject of estimation. We'll solve questions on it of different models. So 2 points to remember: silly mistakes are, so calculation errors basically, that is something which you need to handle carefully in this subject particularly. So you need to have a good understanding on the measurement units, in which units are they asking, because in the numerical questions when they give you a question, They'll also write down which units they want the answer in: square meter, cubic meter, centimeter. So look into the measurement units carefully, and accordingly you need to answer the input box. You need to give in the value based on the given units which they are asking in. And rounding of errors, that is also a type of other than measurement units, errors can also be in terms of rounding off. Many students face an issue in rounding of errors as well. Rounding of error as in when you're doing a calculation at any step, remember this, I'm telling you this in the right away in the beginning. Keep this in mind, not only for this subject, for all the subjects. Whenever you're solving numericals particularly, uh, whenever you round off something while doing the calculation, round off at least to 4 decimal places, 3 or 4 decimal places. For example, while you're calculating something, you're getting somewhere, say, let us say you're getting root 3. Now you need to take 1.732, round off to 3 decimal places correctly, and then solve it. Or even if you're using the scientific calculator, when you do the when you go to the next step, take at least up to 3 decimal places, that is minimum. Ideally you can right away substitute this root 3 itself right away and solve. That will even more reduce your rounding off errors. So be careful with this. In simple, don't take root 3 as 1.7 and then calculate. You might get an answer which is out of range, so you have to be careful on that also. Keep that in mind as well. This, because estimation is a numerical subject, that's the reason I have given you these pointers where you need to keep things which you need to keep in mind. As far as the questions in estimation are considered, as you are aware, estimation basically relates to preparing the estimates, basically to find out the cost of a project. I'm sure you all know the process of how we generally in construction projects, how do we find out the overall construction cost. It starts with the detailed specification. All these are part of the contract documents also generally. So you need to first have an understanding on the specification. Now in the GATE exam, however, questions are focused on the numerical calculation related to estimation. But broadly, the practical application of it, it starts with specification of every item of work. Specification talks about the details of every item of work. The reason I'm just giving you an introduction of this is, one, you should relate to what we are doing, and secondly, there are some theoretical questions, and I'll tell you what are those theoretical questions which can be asked, and what should you from your end, addition to whatever we are solving in the class, what else can you do. I will also talk about that. So that's the reason I'm giving you this introduction. So specifications focuses on the detail description of the item of work. If the item of work is, say, let us say for example, in a building there's a brick wall. Now you cannot just write it as brickwork, you have to explain it. So brickwork of so and so thickness, of so and so bond, English bond, Flemish bond, whatever it is, 1 brick wall, 2 brick wall. So a detailed description of that item of work is called as specifications. Once you have the detailed specification, you can then focus on creating the bill of quantities. In construction we call it as BOQ, wherein you estimate the quantity, which is quantity estimation. Now, in the GATE exam, numericals are mainly focused on this, the estimation of various items of work or the quantity of each item of work. They can give you some description of a room and ask you what is the brickwork. They give you the description of a room and its footprint and ask you what is the damp proof course, estimate its damp proof course. So for every item of work, the quantity is estimated in the when you create a detailed BOQ in an appropriate measurement units. Every item of work will not have the same measurement unit. For example, if you have an item of work which is painting, can anyone tell me, for the item of work of painting, what is the appropriate measurement unit you use generally in construction estimation? Obviously this will be estimated in square meter. And in every item of work there are some exclusions also, like when you are estimating painting on a wall, the exclusions include the door and the window area, the fenestration, basically that comes under the exclusion part. So other than paint work, for example, let us say you have the some other item of work like excavation. What is the appropriate unit, measurement unit for excavation, you think? In general it is cubic meter, but there are exceptions also. For everything there is an exception, particularly in items of work like brickwork and excavation. There are various categories, like if as per the CPWD guidelines. So where do we get these measurement units? One, it can vary from project to project for sure. But in the gate exam, sometimes even the 2025 question paper, if I tell you the theoretical question, that was based on this. They will give you an item of work and ask you what is the appropriate measurement unit. So you have to remember the standard measurement units which are used for some specific frequently used items of work. What is the reference? So this is the point I wanted to tell you about, or ask you to read from your end as well. So what can be an authentic source to understand the measurement units for various items of work? You can check out the CPWD specifications. You can easily find the PDF of this document on the internet. Just search for the CPWD specifications. There are two volumes, volume 1 and volume 2. In volume 1, some items of work are considered, are listed. So every chapter is a different item of work. In the second volume also, so there are two volumes for this. I will not ask, because each of this volume is around say 800 pages or something like that. So if it's not necessary for you to read each and every page, but just go through it, go through the index of the CPWD specifications and try to understand what are the various items of work, and write down in one sheet of paper what are the measurement units. In each chapter they will write down the measurement units for each item of work. So just go through it. Wherever you can find an item of work, sometimes it is possible that you might not find an appropriate unit listed there, you can skip that. So uh, use the index of the CPWD specifications of both the volumes and accordingly write down the measurement units. This can be an important theoretical part under the subject of estimation. So that's something you can focus on. For example, when I asked excavation, you all told me that the measurement unit is cubic meter, which is correct. In most of the instances, excavation is estimated in cubic meter, but there are some exceptions, like as per the CPWD specifications, if I can recall it correctly, if the excavation is having a depth less than 30 centimeters, it is measured in square meter. That's an exception basically. Generally it is cubic meter, but it is estimated in square meter if the depth of the excavation is less than 30 centimeters. That is also mentioned. Other than that, the same excavation work can be estimated in running meters also, if it is excavation done for laying some cables or pipelines. So if there's a pipeline or a sewer being laid, now that is the excavation work which is more of linear in its orientation, right? So based on its properties, so excavation can be in meters also if it is for trenches for cables, trenches for pipelines, trenches for say laying sewers. These are some examples. So every item of work, based on its specification, based on its description, the measurement unit can change. So you can have a look at it. In 2025 paper, there was a theoretical question where they asked what is the estimation unit for brickwork in honeycomb structures or honeycomb brickwork. Now for honeycomb brickwork, as per the CPWD specification, it is measured in square meter. So honeycomb brickwork is basically type of a brick jali construction where you have a lot of openings in it. So for that you estimate it in square meter, because it is non-structural work which doesn't have a significant thickness generally. So long story cut short, remember the measurement units for various items of work which are relevant from CPWD point of view. So that is something which you need to do from your end as well. Uh, that said, why do we measure, or why do we prepare the bill of quantities? Why do you create this list with the appropriate measurement units? We do this to estimate. Basically, after this comes the cost estimation. For cost estimation, you need the rate of each item of work. I'm sure you know what is rate. Cost per unit is called as rate. So if there is painting, for example, cost per square meter will be the rate of it. If there is excavation, cost per cubic meter. So rate is always expressed as cost per unit, and that measurement unit is as per this column. So that's the rate. And once you multiply the quantity with the appropriate rate, you get the cost of that item of work. So you get cost of each item of work. Sometimes there are numericals on estimating cost also, but majorly in the gate examination, if you look at the past papers, majorly the questions are based on quantity estimation. So you need to know the basic understanding of basic formula in geometry, basic understanding of geometric forms and the calculation of it. So that's what the questions mostly revolve around, but not all questions will be only of this type. There are questions on estimation of time, there are numericals based on estimation of cost, so there can be other variations also. So for the purpose of this revision class, we will be taking up, so our focus mainly will be on two things. One, we'll try to cover different question typology under each subject, not only for this, every subject. That would be a focus. We'll try to cover varied typology of questions. Secondly, we'll try to focus on covering at least last 5 or 6 years, particularly if it is numericals. We are going to target on the last 5 to 6 years of numericals. Even theoretical questions we'll try to. So today's lecture is mostly numerical oriented, but in subjects like we have a lecture on history also, I think obviously we'll not have any numerical in the subject of history. So we'll focus on the theoretical questions of the recent past. So we'll emphasize on covering different questions and also recent questions. That would be the focus. Let us look into the, before we start solving some questions, I can give you a brief overview on some basic concepts, numerical concepts, which we'll be applying in various questions. So one thing, you need to have an idea of the basic formula of geometric forms, like cube and cuboid. So in case of a cube, for example, if you know the side of a cube, particularly these formulae are applicable in questions related to the calculation of, say, painting area, plastering area. There are some numericals where they'll give you the size of a room. They'll ask you to estimate the area of the paintwork or plastering or something like that. So basically for cube, there are 6 faces. Each of the faces of same area. If the length of the side is a, the wall area in this case, if in, for example, it's a cube based room, the area of the walls will be 4 into a square, whereas the total surface area including the floor and the ceiling, it will be 6 into a square. Generally, if it is a question on painting or plastering, mostly it would be in so you need to consider mostly the wall area always. Acha, remember one more point, you need to read the question wording also very carefully. Sometimes they ask you questions on estimating paintwork and they'll give you what is estimate the paintwork for the walls. So if they're mentioning walls, you will only consider wall area. Sometimes they might mention wall along with ceiling. So you should not be in a hurry when you solve a numerical particularly. Read it carefully and see what they are asking. So if you look into the cuboid, now this is something which will apply mostly in most of the cases. So if you have a cuboidal room of length L, breadth B and height H, I'm sure you know volume is L into B into H, which might not be applicable in estimating quantities generally, but generally you might need to know the area. So in case of wall area of a cuboidal room, 2h into L plus B. In any point, if something is not clear or if there's any issue in the audio at any point of time, let me know in the chat. I'm assuming that you're able to follow whatever I am speaking. So the total surface area, 2 into LH plus BH plus LB, that would be the formula you apply. These are some basic geometry formulae which we use. Other than this, sometimes there have been numericals on spheres, some other types of solids also, particularly in volumetric form. So let us say, for example, if you have a sphere, the volume, if you remember, sphere is basically a solid with a particular known radius. If you know the radius r, the volume of the sphere will be given by 4 by 3 pi r cube. In the gate examination, you will have scientific calculator. So accordingly, you can use the value of pi from the calculator itself. So 4 by 3 pi r cube is the total volume of the sphere. Area, the surface area of a sphere will be 4 pi r square, but that's not generally applicable. Other than this, you can remember there can be frustum based questions sometimes. Frustum basically, let me just talk about this frustum and then we'll solve some, and then lastly I'll talk about centerline method and then we'll start solving the questions. So as far as frustum is considered, frustum is basically a truncated cone or a truncated pyramid. Truncated as in a pyramid or a cone in which the tip is cut off. The formula is same in both the cases, be it a cone. So first let us try to understand what exactly is frustum. So if you are basically having a conical shape, a conical solid, something like this, in which the tip is cut off. So this is frustum of a cone. So if you basically extend this, you might get a perfect cone as such. So that's a frustum of cone. Similarly, you might have questions with frustum of pyramid. Generally, they'll ask you questions with frustum of pyramid because sometimes this particular form is used for the column footings. In column footings, you use a frustum profile for supporting it generally, something like this, supported on a layer of PCC bed, plain cement concrete. So in any case, so if you are having a frustum of pyramid also, the formula, same formula will be applicable. In both these instances, frustum of a cone and frustum of a pyramid, remember in this, the side is sloping in all the, if I draw the plan of this particular shape of frustum of pyramid, you will have a square or a rectangle on the top, you will have a square or a rectangle at the bottom, and then you will have these sloping lines on all the four directions. It slopes in all the four directions like this. That's what frustum is. Frustum is not a solid where you have a trapezium which is extruded. This is not frustum. I hope you are able to understand the difference. Here I am taking a trapezium and then extruding it in one direction. That is different. Here this particular surface is plane. For this solid, the formula will be different, which we will discuss in a while. So remember, for the frustum, to know the volume of it, you need to know three things. For any frustum solid, be it cone or a pyramid, you need to know three things. One, you need to know the area of the top surface, that is A1, let us say. Area of the bottom surface, let us say that is A2. And the difference of height, the height between the first and the top and the bottom area. If you know these 3 points of information, you can easily calculate the volume of the frustum. Even in this case also, you need to know this particular area of the top surface. Let us say that is A1, and then area of the bottom surface, A2, and the elevation or the height difference between the first and the second surface, this height h. If you know these 3 points, these 3 values, you can find out the volume using this formula. Make a note of the formula of the volume of frustum. Volume of a frustum is given by h upon 3, 1/3 of the height into A1 plus A2 plus square root of A1 into A2. Always, whenever you are applying a particular formula in the gate examination, you can always try to, if you are, for example, if you are confused in the examination, square root of is it A1 into A2 or A1 plus A2, you can focus on the measurement units once. Because we are talking about volume, your answer should be in cubic meter. So height is measured in meter. Whatever is in the brackets, that should be in square meter. So area is in square meter, this also is in square meter. Square root of A1 into A2 only will give you a value in square meter. If you write it as square root of A1 plus A2, you will get the value in meters basically. It will not be in inconsistency. So check for the consistency of measurement units at every step if you are confused in the gate exam. Many times in numerical questions, you can also, if you are unable to think of the approach how to solve it, many times focusing on the measurement units will come in handy. You can solve the question just by understanding the measurement units and the consistency of units. When a relevant situation or question comes, I'll talk about such tricks too if possible. For now, let us look into some numericals from this subject of estimation. Before we focus on estimating quantities, there are basic questions asked with respect to geometry also. So basic geometric forms, they can ask you questions related to that based on simple concepts like Pythagoras theorem as well. I hope you all know what is Pythagoras theorem. Basically, if you have a right angle triangle, you can find out the length of the hypotenuse using Pythagoras theorem, which is opposite to this 90 degrees. So if say this is the length of the hypotenuse, let us say this is value, this length is A and this length is B. Pythagoras theorem, using that, the hypotenuse will be square root of A square plus B square. This will give you the value, the length of the hypotenuse. So basically this simple questions which you just need to apply this concept, such numericals also can be asked in the examination. Let us take up some questions now to understand the typology of questions, starting with simple geometry questions. So we'll start with simple geometry based questions. We'll then look into some numericals with respect to area based estimation, volume based estimation, and centerline method is something which is applicable in many instances. So I'll briefly talk about centerline method when we come to it as well in some time. First, let us focus on this. This was a 2 marks numerical from 2020 paper. A square based regular pyramid has all sides equal to 10 units. Firstly, it is given as a regular pyramid. In geometry, regular pyramid is something where you have all the sides of same length. So you know what a regular, in 2D geometry, What is a regular hexagon? A regular hexagon is something where there are 6 sides all are of same length. Similarly, a regular pyramid also is something where you have all sides of equal length. That's what a regular pyramid is. A square based regular pyramid has all sides equal to 10 units. Its height is dash. That's the only information given. So basically it is given as a square base regular pyramid. In a square pyramid, you will basically have a total of 4 edges at the base and 4 edges along the inclined direction. So basically for the triangles, if you understand the geometry of a square based pyramid, there is one square and there are 4 triangles. All those triangles are equilateral triangles because they have said in the question that everything is 10 units. This is also 10, this is also 10, this is also 10, everything is 10. So basically if you unfold this particular figure, you will get a square and you will get equilateral triangles on all these directions. Right, all these are equilateral triangles because everything is 10. That's what a square based regular pyramid is. Can anyone tell me in 3D geometry, in solids, what is a triangular base regular pyramid called as? An equilateral triangle as the base instead of square. If you have an equilateral triangle as the base, and all the sides are also equilateral triangles basically. So a solid created with this, an equilateral triangular regular pyramid, what is that called as? No, prism is not correct. Prism is very different. Tetrahedron is actually the correct answer. So a triangular base regular pyramid. So you need to have an understanding on these basic solids as well. So if you're having a triangular base and a triangular base regular pyramid, basically there are 3 edges inclined and 3 edges at the base. This is called as a tetrahedron. It's called as tetra is basically 4. It has 4 heads. Every head is basically an equilateral triangle. That's what a tetrahedron is. What is a prism then? Prism is a solid which is created by extrusion. These solids, like pyramid, is not created by extrusion. Pyramid can be created by basically folding the sides of a two-dimensional plane or a paper. But prism is something which is which is generated by extrusion. Extrusion as in you take a surface and extrude it in one direction like this. So that's what a prism is. Prism can be a triangular prism, a square prism, or basically a rectangular based prism can be a cuboid itself. Then you can have a hexagonal prism and so on. Prism is any solid in which you use extrusion and create the three-dimensional form. We'll talk about these extrusion solids as well for understanding the formula for the volume of such solids in a while. So in this question, the given solid is something like this. They're asking us the height of it. Whenever in the question, if it is mentioned as height, remember they're talking about the space height of it. For a solid, there can be space height and slant height both. Here they're talking about the space height because by height we always mean space height. Space height is this vertical height from the tip to the base. That's called as the space height of the pyramid, which basically is the vertical perpendicular distance from the tip to the base. If you drop a perpendicular from the tip, that height is called. So if this is a regular pyramid, but let us say if you're having a skewed pyramid, let us say you have a pyramid something which is skewed where the tip is not coinciding with the center. Even here the height will be this vertical perpendicular drop. If you drop a perpendicular to the base level, this height is called as the height of the pyramid in skewed ones. But I don't think they'll go to you'll get numericals on skewed pyramid as such because it's not relevant, or it would not be much relevant. But still, even in such questions too, you can use simple geometry like Pythagoras theorem, sine, cos, tan, trigonometry. You can find out the value of the height. So here they're asking us this particular height. And just to tell you what is slant height in this case, slant height is basically the height from the height along the face, basically height along this triangular face, height from the tip to the perpendicular dropped along this edge, the height along that surface, the face of a pyramid, that's called a slant height of the pyramid. Do not get confused with the edge. This yellow line is the slant height. This is the edge of the pyramid, which is different. You cannot call this as the slant height. Can anyone tell me what is the length of this blue line? in this question? The distance from the tip to one of the corners, that will be 10 units, because it is mentioned in the question that it is a regular pyramid, so everything should be 10. In any case, to find out the space height, there are different approaches. You can calculate this height in multiple ways. Let me use any one of these approaches. So I will be drawing triangle, a right angle triangle from the tip to the center of the base to one of the corner. So let me highlight this. So this orange triangle, let me draw out this orange triangle joining one corner and the center of the base and the tip at the top. Joining these three things, if you get a right angle, you'll get a right angle triangle, because that's a perpendicular drop like I told you. So if I draw out this right angle triangle from the tip of the pyramid to corner of the pyramid to the center of the base of the pyramid, this height h is to be calculated. This is asked in the question, so let me write it as h. From the tip to the corner, what is the distance? The hypotenuse of this right angle triangle, what is the value of that? That is already 10. The blue line, like I said, that is 10 units. They have not given any other measurement unit, they just mentioned it as 10 units, so you can write it as 10 units. Distance from the center of the base to the corner, for that I need to draw the plan. The plan is basically a square, because this is a square base pyramid. In this plan, we are looking for distance from the center of that base to the corner. This distance I want to know. To know this, it is basically half of the diagonal of the square. Length of the diagonal of the square is basically square root, it is root 2 into a, or a into root 2. That's the value. A is 10 here, so this is 10, this is 10. If you don't know the formula for the length of the diagonal, you can always apply the Pythagoras theorem to find out this hypotenuse. So the overall length of the diagonal of the square is nothing on the hypotenuse, it will be square root of a square plus b square. Both a square and b square will be 10 square and 10 square. So this is square root of 200. This is 10 into root 2. If 10 into root 2 is the overall the diagonal of the square is 10 into root 2, what will be the distance? Can anyone tell me? Center of base to the corner, it will be half of it. So what is half of the length of the diagonal of the square? 5 root 2. So this is 5 root 2, and I'm sure you can apply Pythagoras theorem again to find out the height. So the length of the hypotenuse 10 will be, or you can write it like this, square of the hypotenuse will be a square plus b square. A square is h square, b square is 5 root 2 square. So you can simplify this. 100 is equal to the space height h square plus 5 root 2 square is 25 into 2, which is 50. So you can simplify and you'll get h square as 100 minus 50, which will be 50. Can you even calculate and tell me the final answer? What are you getting? H will be 100 minus h square will be 100 minus 50, which is 50. H will be square root of 50. It's a numerical answer type question, so you need to type in the numerical value up to 2 decimal places they are asking. So tell me the final answer up to 2 decimal places. What would you type into the calculator or into the input box in the exam? 7.07. So square root of 50 is 5 root 2. Root 2 is 1.414. That multiplied by 5 will give you 7.01. So that's the correct answer for this question. So there is nothing which we have applied other than Pythagoras theorem in this question. Such simple geometry based questions can be asked. Let us take up one more example of a simple geometry based question which has been asked in the past. This one, it is based on surface development. So I'm sure you know folding and unfolding. Majority of your architects, and even if you're from planning background, I'm sure you have the required visualization skills for visualizing a 3D form from the unfolded figure. So this is folding unfolding based solid. You need to find out the volume of it. Let us look into the question. The surface development, let me move this somewhere over. The surface development of a three-dimensional object is shown in the figure below. Uh, Let me just check the time because I don't want to run out of time also. Yep. Let us solve this one. Yep. The surface development of a three-dimensional object is shown in the figure below. This is a 2 marks numerical from 2023 paper. Um, the dotted line indicates the folds. The dimensions given in the figure are in centimeters. The volume of the three-dimensional form is dash. So first you need to visualize what is this three-dimensional form you get after folding these edges. So the dotted lines are the folds. So you have to fold along it and stick the edges. Can anyone tell me what solid? Will I get a cube? First tell me yes or no. By folding this figure, will I get a perfect cube? Obviously no, because there are some triangular portions as well. There's a cut over here, then there's an inclined surface also there. So what can you describe this solid as? What three-dimensional solid do you get out of this? Let me move aside so that you can visualize it. Cube with a chamfered edge, absolutely correct. I see a lot of you have described it absolutely correctly. It's like a cube with one of its corner cut off. One edge basically is cut off or chamfered. That's what you get. I'm saying cube because you see this is square perfectly here. The base of it, or basically the size of one side of it at least, this side of it and one other side of it, two sides of it are perfect squares which you can see. So the solid basically will be something like this: a square here, a square here, one corner cut off like this, something like this. I'm sure you are. This is what you will get. It's like a square with one of its corner cut off, oh sorry, cube with one of its corner chamfered. So this portion, if you join, you will get a perfect cube. Uh, can you even tell me what is that cut portion? What is that shape called as? I just told you a while ago actually about that. The portion which you are removing, or what is the missing part of the cube here? That's basically a triangular prism, absolutely correct. It's a triangular prism. Even this solid can be called as a prism. So this also is a prismatic solid, for instance, because the plan of it is uniform. It is having a uniform cross section from top to bottom. So always remember, whenever you have solids, prismatic solids which are having a uniform cross sectional shape, if you're having solids with uniform cross sectional shape, which basically can be termed as prismatic solids or prisms. For such solids, the volume is always calculated by the area. It is calculated by using that area of the cross section or area of the base multiplied by the height of extrusion. So these solids are always created by the technique of extrusion. So in extrusion, in extrusion based geometry, basically in the previous question also, the cross sectional shape is uniform. It is this one, this particular shape, which is a corner cut off from a square. If this you extrude it by a particular height as per the question, you will get the given solid. For all such solids, like if you're having a cylinder for example, that is also a solid with the uniform cross-sectional shape of circle which is extruded. Even a cube and a cuboid also fall into the same category. For all such shapes, the volume is always calculated by the area of the base. In fact, this base will be same as that uniform cross section because the cross section will be same from base to the top. So area of that base multiplied by the height of extrusion. This is how you calculate the volume. This formula is applicable for the walls as well. If in a normal room or a cube or a cuboidal room with vertical walls, the area of such rooms also can be calculated using this approach. You can find out the area of the wall footprint, the base of the wall footprint basically, depending on the wall thickness and all, position of the doors and so on, and the height of extrusion. Could be for rectangle, for brickwork based water tanks in the gate exam. They ask you numericals with brickwork and water tank and so on. So even in such solids you can use the same concept, because if you take this area of the uniform cross section or area of the base, and multiply it with the height of extrusion. This is the height of extrusion. That will give you the volume of brickwork directly. So that is something you can remember. The same logic or concept will apply in this question also. So you need to find out the area of the base, multiply it with the height. First, can anyone tell me by looking into the unfolded solid, what is the height of this solid? Along the extrusion, along the direction of extrusion, what is the height? Is it 1, 2 or 3 in centimeters? The height basically will be this one or this one. So basically this length, right? When you fold it, it becomes the side face on the direction of this. So that height will be 3 centimeters. And we need to know the area into height will give us the overall volume. You can alternatively find out the area of the prism and subtract it also. Either way you'll get the same answer. You can find out the overall volume of the cube, which is 3 into 3 into 3 27. Subtract that triangular volume also, you can do that too. Other than height, let us find out the area. I need to find out this area. How can we basically find out this area? You can easily calculate it by subtracting that triangular portion. So this is a square with its triangle missing, this corner piece missing. So find out the area of that corner piece and then we can subtract it from the area of the square. What is the area of the square if it is complete? What would have been the area of the square? 3 into 3, this will be 9 square meter, 9 centimeter square, sorry. Minus, for the area of the triangle, you need to use half into base into height. For the triangular portion which is missing, by looking into the dimensions of the solid, can you tell me what is the base of that triangle? For this missing triangular form, what is the base of it and what is the height of it? 1 centimeter? 1 centimeter. That's the base and the height of that particular triangular portion. Both are 1 and 1. So half into base into height will be half into 1 into 1. So what is this area? It is area of the overall square, that is 9 minus 0.5. So what is that area coming out to be? Height is 3 centimeters. Area of the base of the given solid will be 8.5 centimeter square because it's area. What will be the final answer? Can you tell me? Volume of the given solid, because it is a prismatic solid created by extrusion, the volume of it will be area of the base into height of extrusion. Area of the base is 8.5, the height is 3, which will come out to be 25.5. Absolutely correct. But this is in centimeter cube. In which units are they asking in the exam? So you need to look into this also carefully. Just to make it complex, now this is straightforward, but just to increase the level of complexity, they can ask you the answer in cubic centimeter, cubic meter also. So if they ask you such question, they can ask you in liters, something like that. They can change the measurement units and accordingly you should be able to answer the question easily. So look into the measurement, but here luckily they have given cubic centimeter, so this will be the right answer directly. 25.5. This was the 2 marks question from the 2023 paper. Easy to score again. Just understand the form and apply the basics of geometry. That's about it. Let us look into, I hope you all are able to follow. Let us look into another question based on 3D solid based calculation, volumetric based calculation. But here, so the previous 2 questions are based on direct geometry. Here they have included one more aspect to make it slightly complex. This is a question from 2016. Hemispherical earth mound of 3-meter dia is proposed to be constructed in a children's park. If the proportion of soil and sand in the construction is 3:2, the estimated volume of soil in cubic meter is that. They'll always mention the measurement units, be careful on that. In cubic centimeter, in cubic meters is dash. So that's the question. So here they're not just asking you the volume of the hemisphere, they have increased one more step of calculation by giving you the ratio and proportion based concept. They are saying that the solid is made of soil and sand both in the proportion of 3:2. And finally they're asking us what is the volume of soil. So first tell me, if the proportion of soil and sand, quantity of soil to sand, that proportion is given in the question as 3:2. If the proportion of soil to sand is 3:2, what fraction of the total volume will be the volume of soil? Volume of soil will be what fraction, what proportion? When I say proportion, you need to tell me how many parts of soil is present in the total. 3/5 of the overall. So soil corresponds to 3 parts. 3 parts out of how much? 3 plus 2, that is 5. So 3 by 5. Volume of soil will be 3/5 of the total volume. Volume of what? Volume of the hemispherical mound. So you need to find out the volume of the mound, and the answer will be 3/5 of it. 3/5 only because they have asked us the volume of soil. If they would have asked what is the volume of sand, then the answer would have been 2/5 of the volume of the mound. So let us find out the volume of the mound first, or you can directly write down volume of the soil is equal to 3 by 5 times the volume of the mound. What is the formula for volume of the hemispherical mound? What is the volume of hemisphere? Half of the volume of sphere. Volume of sphere, I told you already, it is 4 by 3 pi r cube. So here how much will it be? 2 by 3 pi r cube, or rather she is absolutely correct. Yeah, it will be 2 by 3, that it is also right. 2 by 3 pi r cube. So this is what you need to solve. 3 and 3 gets cancelled. So it will be 2 by 5 into pi is 3.14 into, what is the radius here in this question as per the given information? 3 is the diameter. So you have to be careful. This is also a possibility of error. Some students in the examination, now it might sound very silly, and this is exactly what happens in the exam. Mark my word, you will end up having silly errors in the calculation. So your focus should be on minimizing it. If not, if you're not able to 100% remove it, you should at least minimize it. Otherwise, you lose marks in silly mistakes. So be careful on that. So this is diameter. So the radius will be 1.5. The only way to overcome silly mistakes is practice. Focus on practicing as many questions as you can. Solve all the gate papers, solve the mock tests, solve the test series which is given to you. So that's very important. So what is the final answer? You can simplify and tell me. Rounded off to 2 decimal places, tell me the answer. 2 by 3 into pi into 1.5 cube. 4.24 cubic meter. That's the correct answer. They have asked us to give an answer in cubic meter, so the answer will be 4.24 directly. You can see that it is a very simple one. I told you there were 3 numericals in 2016 paper. This is one of it. There were 2 more numericals also in that paper. Uh, Coming back to the next one. So these are some volume based questions. We will come back to volumetric or volume based calculations again in a while. So this one, the next one is based on area based calculation. It is related to estimating, I think, flooring and skirting. They're asking us the number of tiles. So let us read the question. This is for 2 marks question on 2021 paper. It is proposed to have ceramic tile flooring in a room with internal dimensions 1.8 into 2.4. The tile size is 300 cross 300. The door opening is 900 mm and the door is flushed with the internal face of the wall. Height of the skirting is 600 mm. So it's like a dado wall rather than skirting. So it's like 600 mm, 60 centimeter height. Probably something of this height. Then the number of ceramic tiles required for the internal flooring and the skirting is dash, and they're asking us an answer in integer. So you don't round off to the decimal places here, round off to the closest integer if it is not an integer answer. So let us try to solve this. Always remember, in questions related to estimating number of tiles, or say number of cement bags, or say number of buckets of paint or liters of paint, the concept, not for cement bags but for the other instances, the calculation would be something like this: number of tiles required will be the total area of flooring, or total area of tile work. I'm using the word tile work because there is flooring and skirting both here. So it will be the total area of tile work divided by the area of each tile. This will give you the number of tiles. So, excuse me. So what will be the number of tiles in this question? You'll need to first find out the area of total tile work. Clear dimensions are 1.8 cross 2.4. Let me help you with a diagram. You can solve it. Try to solve it from your end and tell me what is the area of tile work you're getting. There will be two components actually, right, in the area of tile work. If this is the overall footprint of that flooring with the height of that skirting, I think height of the room is not given, which is not necessary also. Whatever the room height is, height of skirting is 60 centimeters. So this is how the tile work would be. You need to find out the area of the skirting part and the area of the flooring part. I see some of you, Samina has an answer. I don't have the answer in front of me, but I think yeah, that sounds correct. But let us see. First, let us find out what is the area of the flooring, area of the tile work and flooring, just the base. What is the area of flooring? Length into breadth simply. It is a cuboid, a square, cube breadth, right? Sorry, cuboid, right? So it is 1.8 into 2.4. What is the area of flooring? 4.32 square meter. And then you have the skirting. Skirting, that is basically the vertical part. That one, if this is the height of the skirting, if this is length and this is breadth, the total surface of the vertical planes, the wall area, we already know the formula, it is 2h into L plus B. That's what you will apply over here. But is it completely 2h into L plus B or is there any exclusion? Tell me for the vertical part, the skirting part. There is an exclusion, so that is also something you need to be careful, and intentionally they have given that exclusion also. So be careful with such points. You might end up doing a silly error or silly mistake in this point also. So you need to subtract the door portion. So that overlapping area, you need not take the total area of the door. You obviously you cannot calculate the total area of door also. You don't know the height of the door here. So the width multiplied by that exclusion height. Basically the door width is given as 90 centimeters. I'm doing the calculation in meters, so 900 mm will be 0.9 meter. So this will be 0.9 into height is 0.6. In meters, the height is 0.6 meter. So this you can do. Now the skirting area, how much will this come out to be? 2 into height is 0.6 into L plus B is 1.8 plus 2.4 minus 0.54. 0.54 is basically the exclusion due to door. That you have to subtract. Can you simplify and tell me what is the area of that skirting part coming out to be? After subtracting 0.54, you're left out with 4.5 finally, right? So this is 4.5 square meters. So what is the total area of tile work now? This plus this. The total area of tile work is coming out to be 4.32 plus 4.5, which will be 4.82. 8.82 divided by the area of each tile is 0.3 into 0.3. Simplify this and tell me the final answer. How many tiles are you getting this as? That's the correct answer. So it is straightforward. So mostly in this subject of estimation, you will not have very difficult, there are some difficult questions too, which we might come across when we are solving, but mostly the questions are easy. But there is a possibility of silly errors. So practicing is important for that reason. So, and again, it takes some time also. You need to try to solve it within 3 minutes ideally. Uh, but then uh, the exam, basically when you sit in the exam hall and solve, that is when due to additional factors it's there's a possibility of severe errors. So that's the reason I'm trying to ask you to have an emphasis on the practice. Which one are you having a doubt, Shweta? This question, which part of this question is not clear? Please tell me. The last step, okay. This one, Sweta, is this clear? Area of flooring and area of skirting, the total area of tile work is 8.82. That part is clear? Okay. So basically, for finding out the number of tiles, the approach we use generally is, for example, let us say you have a pathway or something. Let us say there's a road. Let us say this is 1 meter and this is 2 meter. If you want to cover it with tiles of 50 centimeter cross 50 centimeter, how many tiles will you need? So if this tile is, each tile is, let us say 50 centimeter cross 50 centimeter. You will be having two tiles here. The overall width will be covered. So similarly, how many times should you repeat this? Something like that. This is half meter. This is half meter. So it is 1 meter till here. So total it will be 2 meter. 1 meter till here and then the two. So the number of tiles, how do you calculate in this case? How did I get 1, 2, 3, 4, 5, 6, 7, 8 tiles? Basically the total area of tile work divided by area of each tile. Per unit, how much coverage is it having? Total area to cover is 2 square meter. Area of each tile is 0.5 into 0.5, that is 0.25. So that will give me 8. So basically number of tiles will be the total area to be covered divided by area of one tile, area covered by each tile. So that's what we have done. Total area of tile work divided by the area of each tile. But remember, here in this question, the height of the skirting, the internal dimensions in both length and width, everything is a perfect multiple of the dimension of the tile, which means there are no cut tiles actually. In practical terms, the tile dimension is not always a multiple of the length, or the length dimensions of the room is not always a multiple of the tile dimension. In such cases, there might be some additional cut tiles, and in such cases, in practical terms, you consider a 5 to 10% of contingency as an extra part. But in GATE exam, they will not give you questions with assumptions from your end. They will give you questions based, you need to solve based on the given information only always. Right? So I hope you got your answer. Does that clear your doubt, Sweta? Uh, how 2h comes in the formula? Okay, I can explain that. Can you assume door is on one side and subtract the door width from the length and then multiply the height? Absolutely, you'll get the same answer, Dipansh, even in that case. You can do that too. You're free to do that. You can subtract, instead of subtracting the area, you can subtract the door width from one of the length, any dimension, and accordingly you can find it. You'll get the same answer. Logic is same. Uh, Mira, for you, why are we getting 2h in the height in the book? So let me explain that part also. In a cuboid, for the wall area, basically this is L, this is B, height is H. There will be two long walls and two short walls in a cuboidal room. Long wall is something which has a dimension of L into H. This is L into H area. The area of the short wall will be B into H. There will be two long walls, there will be two short walls. In a cuboidal room, there are two lengthwise faces, two breadthwise faces, four faces of wall, right? So 2 into LH, 2 into B, that's the total area. So if you take 2H common in these two terms, you will be left out with L plus B inside the brackets. I can take 2H common. So basically it's like sum of the area of two long walls plus two short walls. Uh, is that clear? Miramad. I hope I'm pronouncing your name correctly. Okay, wonderful. Let us now move on to the next one. This is also an area based question, but this is based on painting Similar concept, similar calculation you need to apply here also. A primary school is having 8 class. So first let us read the question and uh, just give me a second. Sorry for that disruption. So I was telling you in this question, the given question statement is a primary school is having 8 classrooms, each having internal dimensions of 15 into 10 into 4. Uh, Firstly, write down the given information carefully, because if you do the calculation for one room and then forget to multiply it with 8, you will lose your marks again. Having an internal dimension of 15 into 10 into 4. Only the internal walls, you see clearly they have stated only walls are to be painted. Only the internal walls of the classroom are to be are proposed to be painted. Assume a deduction of 10% of the internal wall area for the doors and windows. So they have not specifically given us the dimensions of the doors and windows. They just said broadly it is 10% deduction for the doors and the windows. The specification suggests 2 coats of the paint application. The spreading rate, now when you apply paint on surfaces, the spreading rate will not be same in the base coat and the finish coat. There are 2 coats. In the base coat the spreading rate is 4.5 liter per square meter. In the finish coat it is 2.5 liter per square meter. The amount of paint in liter, how many liters of paint is required, that's the question. So to calculate the liters of paint required, first point in all such questions, be it plastering, painting, first thing is you need to know what is the area to be covered. What is the total area of tile work, total area of paint work. That's what we need to first focus on. First calculate what is the total area of paint work. That's what we need to first find out. First let us find out the area of paint work for an individual classroom, then you can multiply it with 8. The dimensions of the classroom is given as 15 into 10 into 4. 10 meter, 15 meter, height is 4 meter. That's the dimension of the classroom as per the given question. We need to find out the wall area of the walls. You know that the wall area will be 2h into L plus B. Plus 2 into height is 4 into L plus B is 10 plus 15, which will basically be 8 into 25, which is coming out to be 200 square meter. That's the overall area of the wall. But is this the area of paintwork of each classroom? No. Area of paintwork in each classroom, that will be, you need to deduct 10%. So if you deduct 10%, what percentage will be remaining? From 100%, if you subtract 10%, what is the remaining part which is left? 90%. So you need to find out area of paintwork will basically be 90% of the wall area. So let me write that statement also for you. This will be 90% of the wall area, which will be 0.9 into the wall area is 200. So this is 180 square meter. This is for one classroom, but there are total of 8 classrooms. So what is the total area of paintwork? This initial part which we were trying to understand, it will be 8 into 180. How much is that? 1440. Because there are a total of 8 classrooms, 8 into 180 will be the total area of paintwork, which will be 1440. The first part we have completed. Now the remaining thing should be straightforward. Let us find out the paint required for the base coat. The final answer they're asking us to give it in liters. So first let us use the base coat part. For the base coat, the initial coat, the spread rate is given as 4.5 liters for 1 square meter area coverage. How many liters would be required for the total area of 1440 square meters? Simple unitary method. If it's like, if one apple costs 4.5 rupees, 1440 will cost how much? Can you tell me what is the paint required for the base coat? If this is X, you can calculate this value X by multiplying this into this. Unitary method. 6480, absolutely correct. So the value, the paint required for the base coat X will be 1440 into 4.5, which is coming out to be 6480 in liters. This is much it is 6480 liters. Similarly, you have to find out the paint content, or basically liters of paint required for the finish coat. Finish coat spread rate, let me write that over here. Finish coat, the spread rate is given as 2.5 liters only per square meter, for 1 square meter. How much? I'll write it as Y. How much paint is required for 1440 square meter? Simple unitary method again. So the paint required for finish coat, that is Y, it will be 1440 into 2.5. How much is that? 3600 in liters. So what is the final answer? This plus this. Total paint required is 10080 is the correct answer. The answer for this question should be generally you will not have a range in such questions. You need to type the exact answer 10080. Uh, range is given in questions generally where there are irrational numbers or use of if the answer is in decimal points, that's where they give you a range generally. So that's the answer for this question. Don't think that every numerical you'll have a range. Be careful in solving questions, particularly the ones where you need to solve it in integer. Hope this part is also clear to all of you. If anyone has any question, you can ask me. Sweta, because in the question it is given that the primary school is having 8 classrooms. Not single, not one classroom, but 8 classrooms. This 180 square meter is the area of one classroom. So this is 8 class. Is that clear, Sweta? That's what I told in the beginning itself. You need to look into the given information and highlight the information clearly. Yep. So moving on. This next one is again a volumetric one. So the previous two questions were based on area based estimation. Now this one, it is something related to concrete, I guess. They have given some diagram for column footing. Jaya has a question. Can you suggest any site or something where we can learn all the shapes, areas and volumes? Uh, yeah, you can. I cannot recall any particular website as such directly, but you can find what you can do is you can list down the geometric solids yourself, like cube, cuboid, cone, pyramid, cylinder, these basic things, and then the frustum and sphere and hemisphere. That should be sufficient. For these solids, look into the formula for the volume. That should be more. Generally, in the GATE exam, they'll not give you some new type of, they'll not ask you what is the volume of a dodecahedron, obviously. So you can just focus on the basic solids, that should be sufficient, right? So you can list down the solids, search for the formula, you'll easily find it on the internet. That's how you can do. Okay, so let us go into this question. Plan and section of an isolated foundation is given below. The isolated foundation, as in the column footing, basically there is a foundation below a column. The plan and section are given in the figure. The volume of concrete up to the ground level is dash cubic meters. That's the question. You need to find out the volume of concrete in this solid. Uh, Janani has a question. Why do we not use total surface area formula? Generally, because in the question they have clearly stated that, I highlighted it also while explaining, that only the walls are to be painted. If I raise this, they have clearly stated only the internal walls of the classroom are to be painted. You will consider only walls because of that. If they say walls and ceiling, then you will take ceiling area also, you'll add to it. And if they say paint is applied on the ceiling, flooring and all the walls, then you'll take the total. It depends on the question's wording. Is that clear, Janani? So this one. We need to find out the volume of the concrete in this solid. So if you try to look into the plan and the section to understand the solid firstly, so from the ground level, if you start going inwards, the first 1.1 meter depth, it is a straight cuboid, right? So from the ground level, let me use another color. From the ground level till this point, this level, okay, okay, till this level, it is a cuboid. And then at the bottom also, from this level to this level, it is a simple extrusion. So that is also a cuboid. Can anyone tell me what is in between these two cuboids in the solid? So you see the plan also, there are sloping surfaces on all the four directions. So that's basically a frustum of a pyramid, right? So here you need to apply the formula for the volume of the frustum here. So you need to find out the volume of the cuboid plus frustum plus cuboid again. So let us try to find out the volume of these three solids. Give me the values when I ask for it. For the cuboid first, for the first form, that cuboid, it's like a pillar itself. Can you tell me what is this length L, this length in the first cuboid? What is this dimension length? Look into the plan and tell me. 0.25 plus 0.25, that is 0.5. And what is the breadth of this cuboid? If it is not clear, you can check 2020 gate paper. You can check out the PDF of it. But I'm sure, I think it is visible. 0.2 plus 0.2. That is 0.4. And what is the height of this cuboid? So all these questions, whatever we are solving, this PDF of all the questions will be shared with you on the app as well for your reference later on. If you want to check out the questions as well, you can check out from that. So that height is 1.1. So the volume of this will be L into B into H, the first part. So what is the total volume coming out to be? 0.5 into 0.4 into 1.1. Just the first solid, can you tell me what's the volume? 0.22. So this is, they are asking us to give an answer also in cubic meter. So you have to check the given measurement units also. 0.22 cubic meter is the measurement unit for the first solid. The second solid, that is frustum. So let me write the frustum part here. Number 2, the frustum part. So for the frustum, you need to know the area on the top, then you need to know the area at the bottom, and then you need to know the height. Tell me one by one, starting with the area at the top for the frustum solid. What is A1 from the given picture by looking into the given plan? It is zero point 0.2 into, sorry, 0.4 into 0.5, right? Which will be 0.2 square meter. That's the area on the top. Similarly, what is the area of the bottom surface of the frustum? Looking into the plan again, this is 1.25, 1.25, which together will be 2.5, and this is 2. 2.5 into 2 will be 5. And what is the height? Height of the frustum between those two areas? That you can see in the section. It is given as 0.5 meter. Once you have these three values, you can find out the volume of the frustum by using this particular formula. Volume of it is equal to, I told you the formula in the beginning itself, H by 3 into A1 plus A2 plus root over A1 into A2. H by 3 is basically 0.5 upon 3 into area 1 is 0.2, area 2 is 5 plus square root of 5 into 0.2. So what's this volume coming out to be? 1.033. Thank you for the quick calculation. 1.033 cubic meter. That's the volume of the second solid. Let me write it in red over here. For the second solid, it is 1. That's the second solid. Third part is again simple and straightforward. It is a cuboid again. It's like a bed of PCC. Tell me what is the length of it, this one, by looking into the plan. Tell me this dimension of the footing at the bottom. It's not 3, it is 1.25 and 1.25, that is 2.5. And what is this dimension? 1 and 1, that will be 2. And what is the thickness of it? In the section you need to check. It is 0.4. So volume will be L into B into H for the third part. 2.5 into 2 into 0.4. What is the volume coming out to be? Calculate and tell me. The third solid. 2 cubic meter. So the total volume of concrete will be this custom solid, column part and the base PCC bed. Add these three and tell me the final answer. 3 point, rounded off to 2 decimal places, it is 3.25. So the answer finally should be 3.25 cubic meter. That's the answer for the question. Hope this one was clear. So you need to disintegrate the given because you cannot calculate it in a single go. It's not a prism. Had it been a prismatic solid, you can just find out this cross-sectional area and find out the volume, the depth of extrusion, but that's not the case here. Can you tell me in this question, in the same question, instead of volume of concrete, if they ask you what is the volume of excavation, will the answer be same or different? First tell me that. If they have given you the same plan, the same section, and they ask you what is the volume of excavation, what is the volume of earthwork in excavation, all this would become unnecessary because you don't need all this information. Excavation is never done in this shape. This is the shape into which you build a formwork and cast the concrete, but the overall excavation, it will just be a cuboid which will just be a vertical depth of excavation till this depth. So can anyone calculate and tell me what will be the volume of excavation, or tell me the dimensions? If there is a question, if the question is based on excavation, what is the footprint of excavation, length and breadth? This length part, how much is it? If the question is on excavation, just for practice, this is the volume of excavation. This length will be 2.5. Ideally, you take some extra margin for the formwork also, but hypothetically, if you're excluding that formwork space, just for understanding, this will be 2.5. What would be the depth? The other side of the dimension, how much is that? 2. And what is the height of this excavation? Basically, the depth of the excavation, vertical depth. 1.1 plus 0.4 is 1.5. 1.5 plus 0.5, 2. It will be 2, right? 1.1 plus 0.5 plus, so that will be 2. So 2.5 into 2 into 2. How much is that? 10 cubic meter will be the volume of excavation. But again, this is not the correct volume of excavation. If there would have been a question on excavation, they would also give you some margin, extra margin for the form work and all. You need to take at least say 5 to 10 centimeters or something extra over and above this clear dimension. But in any case, Remember, for excavation, you need not find all these intricate volumes. It will be the cuboidal volume itself. Um, okay, let's move on. Let's now look into this next question. Now, this is a bit complex, relatively, if I say. This is a question which can be slightly complex. You can actually solve this using center line method also, which we have not learnt yet. Let us come back to this question in a while. We'll come back to that question after some time. Let us look into this one. This is a easier question. We'll just have a discussion on this. You can solve it for your homework actually. A semicircular, we'll just draw a diagram. I'll share you this document. Like I said, you can solve this question for your practice later on. The question goes this way. A semicircular stone arch of thickness 30 centimeters is provided over an opening in a brick wall. The wall has a length of 3 meters, width of 30 centimeters and height of 3 meters. The opening has a span of 1 meter and a height of 2 meter. That's the information. So if you see, first there is a wall 3 meter in height and length. The thick width is 30 centimeters. So the diagram would be like this: 3 meter, 3 meter. It's a square shaped wall like this with a depth of, with a wall thickness of 30 centimeter. That's a wall. And then they said there is an opening in it. The opening span is 1 meter, height is 2 meter. There's a 2 meter height, 1 meter span. That's an opening. Over this opening, they have clearly said over the opening there is a semicircular arch, and this arch thickness is given as 30 centimeters. I'm writing it as 0.3 in meters. 30 centimeter, that will be 0.3, and the depth of the wall also is given as 0.3. This height is given as 3 meters. This dimension also is given as 3 meters. So that's the diagram. First, let us see what is the question. The first question, they're asking what is the quantity of stonework in the semicircular arch? What is the volume of stonework in the semicircular arch? This one. This semicircular arch based question was asked in 2025 paper also. We will solve that one. This one you can do for your homework. We'll just discuss the concept of it. How do you find out the volume of an arch? Can you tell me an answer in yes or no? Is this arch, the stone arch, is it a prismatic solid? Yes or no? Is the arch created by extrusion? Yes or no? Any solid which is created by extrusion, the concept is same. You take that area, multiply it with the depth of extrusion, you will get the volume. So for finding out the volume of the semicircular arch, you should find out this area. Area of this arch multiplied by the depth of extrusion, this depth. This dimension is given as 0.3. Can anyone tell me what is the dimension from the center of this span to this inner? What is half of the span? The total width of the opening is 1 meter. So that span will be 0.5. And what is the depth of this arch? What is the depth of extrusion? That will be same as the depth of the wall, obviously. That will be 30 centimeters. So those are the dimensions which you need to know for the arch. So you need to find out this area. This shaded portion, first you need to find out the area and then multiply it with the depth of extrusion. That depth of extrusion is 0.3. So you multiply this depth with that surface area. How do you find out the area of this arch or area of the arc? Can anyone tell me which formula or concept you think will be applied here? Yep. There are different approaches you can use. One of it is you can find out the total area of the semicircle till the outer extrados, subtract the smaller semicircle till the intrados line. This part if you remove, that will give you the remaining area. So find out this larger semicircle. Area of semicircle is half of pi r square. So I'm sure you can do that. To find out the area till the outer part, what is that radius you will consider? The bigger semicircle, what is the radius for it? 0.5 plus 0.3, that will be 0.8. What will be the radius you will consider for the smaller semicircle to subtract? I'm sure you can solve it now. So you apply pi r square, r is 0.8 for the larger circle. Subtract pi r square from that, taking r as 0.5. That will give you the area of the shaded portion. That area of the shaded portion multiplied by the depth, which is 0.3. That will give you the volume of the arch. In the second question, they're asking us quantity of brickwork. For brickwork, I'm sure you can simply understand the logic. Volume of the wall, subtract the volume of the stonework in the arch already, and subtract this opening also. This also you have to subtract. I'm sure you can practice this. This is numerical from 2009 paper. Solve this question. I will upload this particular document. You can refer to this also, or you can check out 2009 paper. This is something you can do for your homework. We skipped one question. We'll come back to that. But let us solve this question, and then we'll discuss about the center line method concept. Can we use the formula center line into breadth into thickness? Absolutely, yes, you can do that. Rajeshi, yeah, what's your doubt? Tell me. There are alternative methods of this volume of arch which I'll discuss in this concept. What's the doubt? If you make the arch as an extrusion, then why are we subtracting the stonework from the total brickwork? Rajeshri, because they have said in the question that the arch is made of stonework, right? So stone obviously will not be included again in brickwork. So basically they have constructed all the remaining part with brick. This part they have completed with stone, and this is an opening already. So stone and opening you have to. Yep. Moving on. Let us look into this one. This is from 2025 paper, 2 marks numerical. In a regular semicircular arch of 2-meter clear span, the clear span in the center, that is 2 meter, the thickness of the arch is given as 30 centimeters. The breadth of the wall, the thickness of the wall, that is given as 40 centimeter deep. The quantity of brickwork in the arch is dash cubic meter. Now here the arch is made of brickwork, they are saying. So they're asking us what is the volume of the brickwork. Essentially they're asking us volume of the arch. You can calculate it in multiple ways. Let us follow the same approach which we discussed in the previous question, and I'll briefly touch upon the alternative methods also. So the previous one, the previous method, if you see, you need to find out the area of this arch, finding out the area till the outer semicircle, subtract the area till the inner semicircle, that will give you the area of the strip, multiplied by the depth of extrusion. Let us do this. What will be the, so you need to find out the area of outer circle minus the area of the inner semicircle. That's what we are trying to do. Tell me from the diagram, what is the radius till the outer semicircle? Radius till the outer semicircle? It is 1 meter till here plus 30 centimeters. So that is 1.3 meters, correct. And what is the radius till for the smaller inner semicircle? That will be 1 meter, right? So for finding out the area of this arch surface, you can apply area of the arch surface in elevation. I'm talking about the elevation surface. So that will be pi r square by 2, the half of semicircle, the larger semicircle area, minus pi r square by 2 with the smaller semicircle area. I'm using capital R and small r here. So you can use pi as 3.14, capital R is 1.3, pi 1.3 square by 2 minus pi 1 square by 2. Simplify this and can anyone tell me what is the area of the arch surface you're getting? I'm using this as the capital R, this is the small r. स्क्वायर मीटर में आएगा 0.43. Area of the arch surface is coming out to be 0.43 square meter, I assume. I did not solve it, I'm going by your calculation. Is everyone getting the same thing? Two students have got the same answer, so I'm assuming that is correct. I'm asking area 1.08 आ रहा है? So simplify and tell me the area. 1.08 you're getting, okay. Once you get the area, multiply it with the depth, you will get the volume, which will be 1.08. That's the area multiplied with the depth of extrusion, which is 0.4 meter. So what is the final answer coming out to be? So Jaya, please round off to 4 decimal places at every step. You will get the same answer. So to avoid rounding off error, you have to do that. So if you are using 22 by 7, type this in your calculator instead of pi. If you want to take 22 by 7, take this 22 by 7 into 1.3 into 1.3 press equal to whatever you get without rounding off divided by 2. So otherwise you will have rounding off errors and that will give you wrong answer. Answer will be out of range. Correct? So the answer is coming out to be 0.43 cubic meter. That's the answer. Let me tell you the alternative approach now. This is the one which we can, yep, the alternative approaches, let us see. Instead of solving it like this, you can also use centerline method as well. But before even going to centerline method, there's one more alternative approach which you can use for extrusion itself. You can consider this arch solid. One way of considering is taking this area and then extruding it by 40 centimeter depth. That's one way. Alternatively, you can also consider this particular area, the area of the cross section of the arch. You can take that and you can consider this as the length of extrusion. You can extrude it along this. I'm sure in 3D software, if you see, for example, if you use SketchUp or Revit or any such software, particular in SketchUp, there's a command called as follow me. You take a surface and make it follow, extrude it along a particular line, right? So that's basically what you're doing. You can find out that length of that line and multiply it with the area of this cross section also. So for that, you need to know this length of the center line. So this center line length, which is also called as mean length of the arch. Uh, yep. So this is called as mean length of the arch. The red line which I've drawn, that is called as either mean length of the arch or center line length of the arch. That length you can calculate. Can anyone tell me what is the radius till this center line? What is the radius till the center line? You can observe it here, from here till the center line. Inner radius is 1 meter, then 15 centimeters you have to add because it is half of arch thickness. So this will be 1.15 meter. That's the radius of the center line. So once you get the radius of the center line, I'm erasing this part so that we can solve it here. Taking 1.15 as the radius of the center line, I see someone has a doubt. Uh, Absolutely, you'll get the exact same answer uh, without any error. So, if you know that the radius is 1.15, uh, what will be the length of the center line? Can anyone tell me what formula will be applicable here to find out the length of that arc? Length of the center line of the arch surface will be equal to half of the circumference of the circle, the perimeter. Perimeter or circumference is 2 pi r. This is a semicircle, so it will be half of that. So half of 2 pi r will be pi into r basically. Total circumference is 2 pi r. This will be half of that, half of 2 pi r, which will be pi into r. R is 1.15. So what is the circumference? What is the length of the center line coming out to be? Pi into 1.15. How much is that length coming out to be? 3.6, the round off to 3 or 4 decimal places. 3 decimal places is fine too. 3.611 meter, that's the length of the center line you're getting. Now this length of the center line, you can multiply it with the cross section of the arch. This, what is the shape of this arch cross section? It is a square basically, right? Sorry, cube. A rectangle. What is the dimension of it? It is 30 centimeter cross 40 centimeter. So basically the volume will become equal to the length of the center line, that is 3.611, multiply it with the length and the breadth of the arch, the cross sectional dimensions of the arch, which will be 0.3 into 0.4. You need not by heart any other random formula, but remember this application of extrusion is not necessarily for straight line. The extrusion formula can be applied for curvilinear lines also. If you multiply these three, you will get the answer. How much are you getting it as? 0.4 into 0.3 into 3.611. Same answer. Also, you can use centerline method to find out the area of the arch surface also. So let me tell you about centerline method very quickly, and then we'll come back to this question and see what is the third approach you can use. So basically, in the concept of centerline method, which generally we call it a centerline method. Obviously, I'm not teaching centerline method, long wall, short wall method, and these methods in the class we are not going to discuss here because it's not significant from gate point of view as such. But centerline method, you need to have an understanding of it. Questions can be asked on that. So let me explain you with respect to centerline method. The concept is like this: for any area. So where do you apply this formula of centerline method? It is used to find out area of any surface with a uniform cross-sectional width. If say this is a surface, a strip, a road or a pathway, or it could be a wall footprint, any surface which is having a uniform width. The only concept with centerline approach can be used efficiently when you're having any solid or any area, particularly in terms of area. You can easily apply it when there's an area which is having a uniform width. If you have an area of uniform width, and if you know the length of the center line, let us say this dotted line is the length of the center line, area for that surface will always be length of the center line multiplied by the uniform width. This is the formula you apply: length of the center line multiplied by the uniform. Now this formula is applicable for any surface. It is not necessarily a straight line, it can be an arch also. Even in case an arch, if the arch thickness is uniform without changing, if the arch thickness is of uniform width W, and if you know this length of the center line CL, the area of the arch surface also will be length of that center line multiplied by the uniform width. Not only arch, you can apply the same thing for a room or a cube of a rectangular room with a brick footprint of uniform thickness. Let us say if this is a single room, or let us say it is a water tank made of brick walls, or a water tank made of concrete. If the width is uniform everywhere throughout, even here you can apply the same formula. Find out this total length of the center line from midpoint to midpoint. So that's the total length of the center line, which will be perimeter of a rectangle itself. So that shaded area also will be center line length multiplied by the uniform width of the wall. So the same concept can be applied even in this case also. So if you look into the arch part, you can do that to find out the area directly. In the first approach, inner minus outer semicircle, we applied and calculated this area. Let us use centerline method. Using centerline method, I told you it is length of the centerline multiplied by the uniform width of the arch. That will also give you the area. So area of this arch surface will be the length of the centerline multiplied by the uniform width. What is the length of the centerline? We just calculated a while ago, pi into r. How much is that coming out to be? 3.611. And what is the width of the arch surface? Look into the plan diagram and tell me what is the arch width? What is the uniform width of the arch? Look into the diagram carefully and tell me. I'm asking you about the width, the uniform width of the arch surface. 0.4 is the depth of the arch. The uniform width of the arch, that is 30 centimeters, 0.3. Can you tell me how much are you getting this area as? 3.611 into 0.3? 1.0833, which is exactly same 1.0833. You got the same thing. Once you get that area, you can multiply it with the depth of extrusion. Once you get this area, multiply it with the depth of extrusion, you'll get the same answer. So you can use centerline instead of inner minus outer area, instead of pi r square by 2 minus pi r square by 2, which we used inner minus outer, you can use this alternative method also. Find out the length of the centerline, multiply it with the uniform width of the arch, and you will directly get the area of the arch surface multiplied with the depth of extrusion. You will get the answer for the volume. That is also something you can apply it for the wall footprints also. We'll solve a question on wall footprint as well. But remember, okay, clear till here? Please give me a confirmation. If anyone has any question, feel free to ask. If you give me a confirmation that it is clear, I'll move on to the next point, which is the exclusions in centerline. Sometimes there are some exclusions which you need to consider. Okay. In case of centerline method, when you apply it for the wall footprint, sometimes there are exclusions. Exclusions are seen particularly in T-junction and cross junction. If in the wall footprint there is a junction, so basically if it is a straight wall, then there is no exclusion. Directly you take the length of the centerline, multiply it with the uniform width, you will get the area directly. This length of the centerline multiplied, you can directly do it. Even if the wall is taking a 90-degree turn or any other angular turn, along those turns also there is no exclusion. Whatever, if it is a square shaped room or something like that, so you can find out the area of such strip also, length of the centerline multiplied by the uniform width directly. That is applicable. But in case of T junctions and cross junctions, now I can explain you the reason also. Uh, it If you can understand it is well and good. Otherwise, it can, if I explain slowly, it will take more time. Let me very briefly explain you. So if you consider this particular center line, if you break it into two parts, this line and this line separately, this line will give me area till here, and this second piece of line will give me area till here. Correct? If you zoom in and see carefully, there is this green rectangle and the blue rectangle. The green rectangle and blue rectangle which you can see in this diagram, is it covering the entire wall? Yes or no? Both combined, both together, is it covering the complete wall which you see? Obviously no. A small portion over here that is missing, actually that is not being covered, this part. But the good thing is the exact part is getting overlapped also. The exact same portion is getting overlapped as well, so it is being counted twice. You're counting it in the green rectangle, you're also counting it in the blue rectangle. So basically, even though there is some part which is missing, that is compensated by the overlapped portion. That is the reason there are no exclusions. You're not getting any exclusion in centerline method. So basically, in centerline method, you don't get any exclusion when wall takes a turn. So in the building construction terminology, the edge where wall takes a turn is called as a coin, Quoin. At coins you don't have any deduction in the center line length, because there is a compensation, so that balances up so the neglected part is being balanced by the overlapping part. However, This doesn't happen if it is a T-junction. In case of T-junctions, there will be some overlap part which is multiple times being counted. Let us consider a T-junction, for example. I'll just explain you the detail about the T-junction. For cross-junction, you can understand or think about it yourself. So if this is a T-junction, if you know this length, so let us say there's a wall which is in the form of a T-junction, and this is the total center line length. If you take this total, the dotted part which I marked, that is the total length of the center. If you directly take this total center line length and multiply it with the uniform width of the wall, you will not get the actual area. Let us try to understand why. The horizontal line, let us say that will give me this particular area of the wall, the horizontal wall, that complete area. And then the vertical center line, that will give me the area till here. Can anyone tell me what portion, what is the length of overlap? I'm not talking about area. Tell me the length of overlap. How much length of the line is overlapping, or how much is extra? How much is counted twice? Half of the wall. So if this is the wall thickness, this will be W by 2. So this W by 2 is an exclusion. You have to deduct that. This is called as deduction. Half of wall thickness has to be deducted to find out the area. So in this case, if it is a T-junction of a wall, the area of the footprint will be calculated by the total length of the center line minus the deduction of W by 2. That will give me the effective length of the center line, then multiply it with the width. So basically what I mean to say is, there is so this part, remember, half of wall thickness is called as deduction. Deduction in what? Deduction in center line length. You have to deduct W by 2 and say, why do we deduct W by 2? Because this is overlapping portion like I explained. So how much is that deduction? It is half of the wall thickness. So that you have to deduct from the dotted line length. The dotted line length is center line length, let us say CL. So by looking at it, CL is the dotted line. That you subtract W by 2 from it, then multiply it with the wall thickness. That will give you the area without any overlapping as such. So there is a deduction of W by 2 for T junction. Remember, in centerline method, for a T junction, there is a, how much is the deduction? The deduction will be half of the wall thickness. Similarly, for a cross junction is basically double this T junction. But we have to deduct for only specific overlapping area. Yes, Neha, that's what it is. The length corresponding to the overlapping area, that is W by 2. So that's the reason you're deducting it. If you want to deduct area, you can also do it like this. Center line into uniform width minus, what is the overlapping area? It is W by 2 into the uniform width. The width of it is W itself. This is W by 2 into W. So you can take W common in both. So you'll get center line length minus W by 2 into that uniform width. Right? Same thing it is. So this is basically the overlapping area. Right? So that's this and this are exactly same. So for cross junction, the deduction will be W. So basically, if there are two walls crossing over one over the other, if there is one wall in this direction and the other wall in this direction, if there are two walls, this is the length of the center line, the total deduction will be this overall length W. So that is something you can remember it as standard. It is basically double of the T junction. There is T junction on one side, T junction on the other side. If you want, you can draw such rectangles and understand. It's very simple actually. If you draw the green rectangle in this direction, blue rectangle in this direction, you can clearly see this complete portion is overlapping and it is being counted twice. You have to deduct that uniform width W once as a deduction. So cross junction, the deduction will be W. This deduction will be applied in the center line length to find out the effective length of the center line, to multiply it with the uniform width to get the area. So that is something you can remember in the concept of center line method. I think we solved this. We will come back to this particular question. There will be, if you apply centerline method in this question, there will be deductions. Can you tell me? Can anyone look into this diagram and tell me if I have, we'll read the question, but just by looking into the print, this is basically slab and the beam network. So there are beams intersecting. Can anyone tell me at this point how much will be the deduction in the center line if I want to use center line method here? What will be the deduction to be applied at this point? Half of the width of the beam. These are beams, so it will be half. And what will be the deduction you will apply at this point? It will be width of the beam. So you need to see how many T junctions are you having. So okay, tell me, will you have any deduction here at this corner? Here? There is no deduction. So you need to see how many T junctions you're having and how many cross junctions you're having. And accordingly, all these points you need to accommodate the deductions to find out the effective length of the center line. If you want to use center line method in this question, which we will see in some time. Let us solve some easier questions first. We'll look into that question at the end. This next question, it is related to the concept of damp proof course. So let us try to understand about the concept of damp proof course. Now, a room of, let us read the question, we'll understand what is damp proof course with the help of this question itself. A room of internal dimensions 4 into 5 into 3.5, 3.5 is the height, has 20 centimeter thick walls and two doors of size 1 into 2 meter. The required area for damp proof course is dash. So let me draw the footprint of the room. It is 4 meter, 5 meter, that is internal dimensions. 4 by 5 meter, this is the room. Four meter, 5 meter, and the wall thickness is given as 20 centimeters, that is 0.2 meter. Height is 3.5, and there are two doors 1 meter into 2 meter. If the door size is 1 meter into 2 meter, can you tell me what will be the width in those two dimensions? Which is width? 1 meter and 2 meter. दोनों dimensions में which is width of the door? Obviously it is 1 meter. ऐसा तो नहीं होगा 2 meter width है. This will be 1 meter width. This will be 1 meter width. So that's how it is. We need to find out the damp proof course. Remember, now to answer this question, you need to know what is damp proof course. You need to know which area it is. You should not find out the total flooring area. That's not what damp proof course. Damp proof course is applied on the footprint of the wall. It is basically a impervious layer which protects moisture, which protects the wall from absorbing moisture due to capillary action. That's what it does. So damp proof course is applied in this remaining area. So the shaded portion is the deduction for damp proof course. You need to find out the area of the wall footprint, subtract this shaded portion. So to find out the area of the wall footprint, let me use centerline method. The exclusion part I'll subtract later. First, let us see what will be the dimensions of the centerline rectangle. By looking into the diagram, can anyone tell me what is the length and the breadth of the centerline rectangle? What will be the dimensions of the centerline rectangle? Wall thickness is 0.2. So from the midpoint here to the midpoint here, how much is it? 4.2. It will be half of the wall thickness you add on the top, half of the wall thickness you add at the bottom. Similarly for 5 meter also, half of the wall thickness you add on the left side, half of the wall thickness you add on the right side. So the dimensions of the centerline rectangle will be 5.2 cross 4.2 meters. Why 5.2 and 4.2? Because you need to add half of wall thickness on each side. That's how centerline rectangle area will be, dimensions can be found. What will be the length of the centerline? Perimeter of rectangle is 2 into L plus B. 2 lengths and 2 breadths. 2 into L plus B is the length of the rectangle. So perimeter of the rectangle. So what is the length of the center line? That will be 2 into length is 5.2 and the breadth is 4.2. So what is the center line length? Can anyone tell me total? 5.2 plus 4.2 is 8.4. 8.4 into 2 is 9.4. Sorry, 9.4 into 2 is 18.8. That's the length. What will be the deduction in the center line for damp proof course? Length of the center line for damp proof course. For damp proof course, you need to deduct the length of these doors. How much is the total deduction for damp proof course? It is 18.8 minus. For damp proof course, you don't apply it below the doors. Damp proof course is only applied below the brick walls. So that will basically be 1 meter and 1 meter, which will be 2 meter. So for after considering 2 meter deduction, you will get 16.8 meter as the length of the center line for the damp proof course. Once you get the length of the center line, you can find out the area of damp proof. Always DPC is calculated, is estimated in area, in square meter. So what is the area of the damp proof course? It is length of the center line of the damp proof course multiplied by the uniform width of the damp proof course. The length of the center line of the damp proof course is 16.8. What is the uniform width of the damp proof course? That will be same as width of the wall. Jitna wall hai uske niche, what you just apply the damp proof force below the wall, which will be 0.2 meter. How much is that coming out to be? 3.36 is the correct answer. There are many alternative ways you can solve this question in. You can find out the total wall footprint and then deduct the shaded portion separately. You can use outer rectangle minus inner rectangle also to find out the area of wall footprint. There are n number of ways you can solve this question. Damp proof course calculations, they have not deducted the door length. That must be due to some error, Deepti. If you have any such doubts, you can post, you can take a picture of it, share it on the faculty doubts number just for clarification. But yes, you have to deduct it. Nagarajan, it is deducted for the door. Wherever there are doors, because in the doors there is no capillary action, so you deduct that. Wherever there is brick, you deduct only. You don't deduct it. Correct, Sneha. It is area of the portion where you have the brickwork. Nagarajan, can you confirm? So basically it's like this. If you have a door, there is no capillary action happening here, right? So you apply damp-proof course at this point. You apply damp-proof course by mixing some chemicals into the cement paste and you apply it as a mortar basically. That is to block moisture from entering in, to block it. You don't have damp-proof course in the door part. Okay. Wonderful. Let us now move on to the next concept. This one you can solve for your homework. I'll skip through it. It is the same concept. Basically, they have given the dimensions of the tank, length, breadth, and height. The wall thickness is given. Volume is being asked. You know how to calculate the volume? Find out the area of the wall footprint, multiply it with the height of the tank, that is 4 meter. You can easily find out the volume. You can use centerline method even here. Correct? You can do this for your homework. This question let us solve. First read the question. This is a 2 marks question from 2024. The following figure shows, so after this we will solve the 2022 the lab question and then we will move on to the next subject of project management. This is the last but one question. We'll solve one last question after this. The following figure shows excavation plan of 2-room structure. This is the 2-room structure. So this is the excavation plan basically. This is earthwork to be excavated. Where the trench has a uniform width of 1.1 meter, which is marked in the plan also. If the cumulative length of the center line, the total length of the center line, cumulative as in total, the cumulative length of the center line is given as 41.1 meter and the required depth of concrete to be poured is 30 centimeter, that is 0.3 meters. The volume of concrete in the foundation in cubic meter will be dashed. To find out the volume of concrete in the foundation, basically you will need to find out the area of the footprint multiplied with the depth. That's how you can find out. Volume of concrete in foundation is to be calculated. That basically will be the area of excavation footprint area of the shaded portion basically that I'm writing as excavation footprint, multiply it with the depth of the foundation, depth of the concrete in the foundation. That's how you find out the volume, area of the excavation footprint multiplied by the depth. So to find out this area of the excavation footprint, We have to use centerline method because centerline length is given. Tell me one thing, is there any deduction, yes or no? If you want to apply centerline method in the cumulative length of the centerline, do you need to, is there any deduction, yes or no? Yes, there is. How much is the total deduction? If the width is, if the uniform width is taken as W, what is the deduction at this T junction? In terms of this W, what is the deduction at this T junction? W by 2. What is the deduction at the next T junction? W by 2. Do you have any deduction at this corner? No deductions for the corners, only T junctions you have a deduction. For cross junctions also you have a deduction, W by 2 and W by 2. So you have to deduct W by 2 two times. So the total deduction will be W. So for the area of excavation footprint, you need to find out the cumulative length of the center line minus W. Basically, for clarity, let me write it like this: minus W by 2 minus W by 2. I need to W minus W. I need to subtract half of the width two times because there are two deductions. That is the effective length of the center line after deductions, that multiplied by the uniform width. That will give me the area. I hope you are all able to follow. This is just area into the depth of the foundation. So basically this is the effective cumulative length minus deductions. This basically will give me the effective center line length for the excavation. Once you get the effective centerline length for the excavation after deduction, you multiply it with the uniform width. Length of the centerline minus multiplied by the width will give you the area. That shaded area multiplied by the depth will be the final answer. So let us simplify this. What is the given cumulative length? It is given as 41.1. From this, you need to subtract W by 2 two times. W by 2 and W by 2 will be W, which is 1.1. So the total deduction is 1.1. This is the effective length of the center line for the foundation, for the excavation trench. Multiply it with the uniform width, that is also 1.1. This will give me the area. I hope you're not getting confused. This is 40. The center line length will be 40 into the depth 40 into the uniform width is 1.1. What is the depth of the concrete as per the question's information? It is given clearly as 0.3 meter. Remember, if they give centimeter, sometimes they do give in centimeter. Be careful with the measurement units. You need to convert it into meters. You need to maintain consistency of units throughout. So don't do a mistake on that part. What is the final answer? Tell me. 40 into 1.1 into 0.3 will be the answer, which is 13.2 cubic meter. That's the correct answer for this question. So this is how you can find out the volume of concrete in the foundation. Let us look into the question which we skipped in between. Let us go to it. I think in this okay, this one. This will be the last question which we'll be solving. You can solve this question also in multiple ways. Is there any question? Someone with the name KAV? I don't know what your name is. Are you asking in the input box, should we type 13.20? Is that what you're asking? Don't worry. That's not an issue. Even if you type 13.2, you will get your marks. That's not an issue. That's actually a standard, it's which they generally write round off to two decimal places. 13.2 should be fine enough. That's not an issue at all. And again, that said, you can try typing 13.20 also. That will not. So, but in simple terms, if you type 13.2, you will not lose your marks for sure. The next question. Because see, in the GATE exam, the official pattern, how it works is they give you an answer key range if it is in rounded off. So they can give something like 13.1 to 13.3. So So even if you type 13.21, probably you'll get your marks. But ideally, don't do an intentional error. Type whatever you get. 13.2 should be fine. Let's look into this last question. The reflected ceiling plan and section of a RCC roof uh, are shown in the figure below. All the beams are 300 mm wide, 600 mm deep, including 150 mm slab. So the beam depth is 600, but that includes the 15 centimeter slab also. That's what they are saying. Equidistant, which is marked over here, 15 centimeter slab, equidistantly placed center to center. All the beams are equidistantly placed center to center. Assume 1% of the concrete volume to be occupied by the reinforcement bars. The volume of the concrete is dash. They're asking us volume of the concrete in cubic meters. So you can use centerline method to find out the volume of the beams basically that you can do. Alternatively, you can also find out by deducting these depressions. So basically, if you look into this reflected ceiling plan, it's like a cuboid, overall cuboid, this part if you see, with some punctures in it. So these depressions you can deduct, these voids. You're not filling it. Basically, there are voids between the grid of beams. You're having a grid of beams between which you have voids. These voids you can subtract. You can find out the overall volume till the outer part and then subtract those voids. Either way, you'll get the same answer. We can use any one method and we'll solve. Let us solve it using the centerline method in the class. You can do the subtracting the voids method for yourself for your practice. I personally feel that subtracting voids method is easier. But still, let us look into centerline method because it will be a practice for you. So, can you count and tell me how many beams are you having in total? Oh, basically, if you want to find out the total length of the center line of the grid of beam, okay, let us do it like this. First, there is slab on the top, and then consider the grid of beams at the bottom separately, right? Tell me what is the volume of the slab. Volume of slab is directly a cuboid, so you can directly calculate. What will be the volume of the slab excluding the beams? So practically speaking, beams are integrated into slab that way. So excluding that, what is the slab considering the grid of beams below it separately? What is the dimension, length, breadth and height? Length, breadth is 10 meter and 10 meter. Tell me the thickness. 10 into 10 into 158 mm, that is 0.15. That is just the slab part on the top, which is coming out to be 15 cubic meters. Other than that, you need to say the grid of beams at the bottom. So if you look into the grid of beams, let us use centerline method for the grid of beams, which you can see in this diagram. That is the grid of beams. Tell me, if you want to find, we'll subtract the deductions later on. First, let us find out the cumulative length of the center line. To find out the cumulative length of the center line, how many, all these lines will be of same length? There are 1, 2, 3 and 4 horizontal lines, 1, 2, 3, 4 vertical lines. All the lines will be of same length. Tell me what is the length of each line in that grid? For the grid of beams, to find out the volume, I'm first finding out the cumulative length of the center line. How much is the cumulative length of the center? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 lines. What is the length of each line? Carefully look into the diagram and tell me what is the length of each line. I'm talking about the center line here. So accordingly tell me what is the length of the center line from here till here. It is not complete 10. You need to subtract Harshank, 0.6 is the depth of the beam. I am considering just the slab excluding the beam. That's what I said. Beam को अगर separate कर दिया जाए, सिर्फ slab का thickness क्या है? That's what I asked. It is 15 centimeters. This one. I hope you are able to visualize that, Harshank. You need to visualize a bit to understand this. I think many of you have given me the correct center line for the for the beam. That center line basically will be half of the beam thickness at the top, half of the beam thickness you need to subtract at the top. So the total deduction will be 0.3. 0.15, 0.15. So that will give you 9.7. That will be the length of each line of the center line for the beam. So that will be 8 into 9.7. What is the cumulative length of the center line coming out to be? 8 into 9.7. How much is that? You can use your calculators. 77.6. You're getting cumulative length of the center line in meters. Now from this there will be some deductions for the junctions. Tell me, how many cross junctions are you having? How many cross junctions are you having in that grid of beams? There are 4 cross junctions, 1, 2, 3, 4 in the center. And how many T junctions are you having? There are 4 cross junctions. How many T junctions are you having? These red ones are the cross junctions. Blue ones are the T junctions. 1, 2, 3, 4, 5, 6, 7, 8. Fine. There will be a total of 8 T junctions also. So for every cross junction, the deduction is W. For every T junction, the deduction is W by 2. So what is the total deduction in terms of W? It is 4W plus 4W. What is the total deduction? 8 times the W, right? So 4 into W, 8 into W by 2. The total deduction. Can you even tell me what will be the total deduction? Center line for beams after deduction. 77.6 minus the total deduction will be 8 into 0.3. The beam thickness is 0.3. 300 mm it is marked in the diagram also. That is 77.6 minus 2.4. So what is the center line for the grid of beams after deduction coming out to be? 75.2 meters. That's the length of the center line. Once you get the effective length of the center line for the grid of beams, you multiply it with the width, the uniform width, to get the area. So basically that will give you this overall area of the grid of beams. This complete area you will get this plus this overall area along with this grid of beams. So this grid of beams area you can find out by multiplying this center line with the width. So the area of grid of beams in the given diagram, that will be the length of the center line, which is 75.2, multiply it with the uniform width. What is the uniform width of the beam in the plan? To find out the area, what is the uniform width? You need to multiply it with uniform beam width is 0.3, 300 mm it is, right? So multiply it with 0.3. So what is the area of the grid of beams coming out to be? 22.56. Once you get the area, you can multiply it with the thickness of the beam to get the volume. So what will be the volume of the beam? Volume of all the beams below slab, not including the slab part, but below the slab, that will be this area 22.56 multiplied by the depth. Can anyone tell me what depth will I take? Will I take 15 centimeter, 30 centimeter, 60 centimeter or 45 centimeter? Now you need to take only 0.4 because I'm talking about that part which is below the slab. Slab is already 15. So it is including slab 600. So the remaining part will be 450 below the slab. So 450 is nothing but 0.45. 450 millimeters it is. In meter it will be 0.45. So what is the volume of the slab? Sorry, volume of the beams below the slab. How much is that coming out to be? 22.56 into 0.45. Round off properly to 2 decimal places and tell me. 10.15. That's the volume you're getting, and this is the volume of the RCC, the slab on the top, volume of the beams. Together, what is the total volume of RCC? This is not the final answer yet. What is the total volume of RCC? It is 10 plus, sorry, it is 15 plus 10.15, which is coming out to be 25.15. But this is the total volume of RCC. They have said 1% is reinforcement. So what will be the volume of concrete? Volume of concrete will be, can you tell me in percentage, if you deduct 1% as steel, how much percent of RCC is concrete? What percentage of the RCC is concrete? 99%. So the answer will be 99%, that is 0.99 into 25.15. So tell me the final answer. 0.99 into 25.15. This I'm doing because there is 1% deduction, that is assuming 1% of the RCC is occupied by the reinforcement bars, they said. So final answer will be 0.99 into 25.15. 24.9. That's the final answer for this question. I told you, you can also solve this by deducting these voids, which actually will be easier also. But still, I wanted you to visualize and understand centerline method and how it is applied. That's the reason I used this method. Alternatively, for your homework, practice the same question. You'll get the exact same answer using the deduction of voids method also. Everyone clear? If anyone has any doubt in this approach and at any step, you can let me, I will repeat that step for you. Anyone having any doubt? Please give me a confirmation if it is clear. So once you give me a confirmation, we'll move on to the next topic. Clear? Wonderful. Chalo, let us look into the, I'll not give a break. I think that should be fine because it is half an hour only more. I hope that is manageable for you all. Do you people want a 2-minute break? Cumulative length, I'm not sure what your name is. A सिर्फ initials दिख रहे हैं. Cumulative length is basically the overall length from the diagram. Like in this diagram, the cumulative length is this total length of the center line, including the overlapping part. So the length of the center line from the diagram, including the overlapping part, is called as cumulative length. Is that clear, AA? Yeah, chalo. So from cumulative length, you need to deduct those overlapping portions. So fine. There's one more question on estimation actually from this power shovel. You can solve this for your homework. It is simple unitary method. You people can take a 2-minute break. We'll continue after 2 or 3 minutes, not more than that. Be back because we need to complete the basics of project management as well. Be back in 3 minutes. We'll continue. Let us continue. We'll now look into the details of this subject, some basics about the subject of project management. Uh, I'll just focus on solving some basic typology. Of course, Sneha, the question I think, are we going to cover probability related sums? No, Sneha, we are limiting ourselves only to the common part, architecture and planning part. So we're not going to cover general aptitude portion. So probability, I don't think will be covered in this particular series of lectures. That's something you need to do from your end. Um, so, I was telling you that this particular subject in itself is a vast one. It's not practically possible for us to do everything in half an hour, but we will cover some repetitive portions. So mainly there are three areas which we will focus on. I cannot teach you the basics of how to draw a network diagram, but I'll solve one or two, a couple of, at least one question where we'll draw a network diagram and solve the question so that you know how to draw, and we'll solve some questions on from the network diagram given also in the question. So I'm not going to teach you the basics. I'm not taking you right away from the basics because this is a revision class. So we'll focus on some basics of PERT, one basic formula, which is the most repetitive one on PERT. PERT is basically program evaluation review technique. I'm sure you know in exams you get questions, so theoretical questions of full form also. In GATE, they have asked this in the past. Uh, Program evaluation review technique. Other than critical path method, program evaluation review technique is another widely used approach in project management. So we'll learn one basic approach of PERT. We'll then look into one basic, a couple of basic questions related to the network diagram. In terms of network diagram, basically critical path method, CPM. And finally, we will be looking into the float calculations. There are four types of float. I will give you the four. I don't think we'll have sufficient time for me to explain it in detail, but I can give you the formulae for the four types of float, and I will solve a couple of pass gate questions from this part. Uh, Sure. So that let us first complete this and we'll see if you want me to explain, I can do that towards the end. First, let us complete this portion. So with respect to PERT, one of the most repeating part or repeating concept in the exam is related to the calculation of the expected duration. So in PERT, remember for in PERT model, basically each activity, I hope you know what is activity in project management. Activity is basically a portion of the overall work which consumes resources like time, material, labor, and money. That's what an activity is. And each activity in PERT model has three time estimates. Unlike critical path method is a deterministic model. In CPM, critical path method, which is based on deterministic model, here each activity has a defined single point duration. For example, if you look into this particular diagram, there are various activities A, B, C, D, E, F, so on. Each activity has one duration. A has 7 days, D has 8 days. So this basically is a network where you have a fixed duration for each activity. So this is called as critical path method, which is deterministic model. Whereas PERT is based on a probabilistic model. Because it's based on probabilistic model, each activity has three time estimates. You don't have a fixed duration here. You have three time estimates for each activity in this model. And these three time estimates are called as optimistic time estimate, most likely time estimate, which is also called as model time estimate, and TO is most likely time estimate, which is also called as modal time estimate, and TP is pessimistic time estimate. There are three time estimates for each activity input. Using these three time estimates, uh, is the network clear to all of you? Please give me a confirmation. Is the audio and video clear? Is the audio video clear now? Okay, let's wait. Let me just see if I can connect to an alternative connection. Just give me a moment. Is the audio and video better now? Please give me a confirmation in the chat. Nope. I hope it should be better now. Can you please confirm, is the audio clear? Okay. So I was telling you that in PERT, each activity has three time estimates. You have optimistic time estimate, most likely also called as modal time estimate, and pessimistic time estimate. These are the three time estimates you have for each activity in PERT. Basically, the meaning of these time estimates is, so because it's a probability model, for example, if you have an activity in project which is say painting the walls. Now painting the walls, if you're using critical path method, the activity of painting in this model, you will have a fixed duration. When you as project manager, if you're using critical path method approach, you'll have a fixed, you'll see how many days will painting take. Let us say painting takes 7 days. You fix that duration. So there's a fixed duration for each activity. You don't take multiple scenarios. You just take one scenario, one value for duration. But in PERT, because it's a probabilistic model, you take different scenarios. You take a best case scenario, which is the optimistic मतलब positive, most positive case. So optimistic time estimate is basically the minimum time estimate. What you think is the best minimum time in which you can do the activity, that is optimistic time. Similarly, you also take a pessimistic time. In worst case scenario, what is the maximum time which the activity takes? So for example, if you're using PERT model, as an example, let us say you have an activity painting. Now this, you'll not take a fixed duration in PERT model, you'll take three possibilities. A best case scenario, optimistic time estimate, let us say the minimum time to do this activity is 5 days. So you'll take the optimistic time as 5 days. And let us say the worst case scenario, in worst case scenario in which there are delays due to availability of material, labor, so on, or let us say your site is located in Delhi and suddenly there's a rise in pollution and there is GRAP 4 which is implemented, so your activity, construction activity will be banned basically. So something of that sort has happened, and due to which in worst case scenario, let us say your painting is going to take 15 days. So that's the maximum time estimate. That's called as pessimistic. Pessimistic is basically the opposite of optimistic. It's like the worst case. You consider the all what bad can happen. You consider that and then see what the time is. So that's another scenario. Most likely something between them. It's not necessarily the midpoint. Most likely time estimate is basically the modal value. Modal value as in, so basically if you are going and asking 100 different people what will be the time for painting. Let us say you'll ask 100 different painting contractors, how much time will you take to paint these walls? Everyone will give us, some will say 5, some will say 15, some will say 7, some will tell 8. Everyone will give their own value. The minimum value is 5, maximum value is 15. All the other 98 people will give their value something between 5 and 15, including 5 and 15. They can give 5, 15 or something. So the most repeated value out of those 100 survey points, whichever value is more. I'm just giving you an example here. So most repeated value, that is modal value in statistics. You know, mean, median, mode is basically the most repeated value. Something similar is used over here. Modal time estimate is also the most likely time estimate, which can be anything between 5 and 15, including 5 and 15. It can be 5 also, it can be 15 also, it can be something between like 10 also, it can be 8 days also. So whatever most repeated value you have, that is taken as the modal time. So in PERT, this approach is followed. You don't have a fixed duration for each activity. It is a probabilistic model. You take different scenarios, best case, worst case, and most likely case, and there will be 3 time estimates for each. Only 3, not 4, not 5, only 3. These 3 are the fixed names for it. In PERT model, this is how the duration is defined for each activity. Now, can you tell me, if I ask you a simple, you get theoretical questions on this part, that's the reason I'm asking you. So this is a CPM critical path method is called as a deterministic model, and PERT is called as a probabilistic model. Can you tell me, if you're having a residential building, something which is only ground floor residential building, a small project, just a 2 BHK house, nothing else, a simple project, simple house. So can you tell me which approach in project management you think will be ideal for such projects, CPM or PERT? Obviously something which is simple and straightforward. Simple and straightforward is CPM. So because the reason is, if in a small residential project, let us say there's a small plot, you want to know how many days will it take for excavation. If you ask 100 different contractors, how much time will you take to complete this excavation for a small 100 square meter plot? Will you get almost same values, or you will get highly different values? Will you get almost same, okay, variation? Will it be less variation, or will you have a huge variation? You'll have very less variation, almost same, because there's nothing new or rocket science there. It is a repetitive project. Everyone knows about it very well, so everyone will give you the same time estimate that it'll take 2 days, or it'll take 1 day, whatever. So that is not having a huge variation. So critical path method is generally used for small projects on which there is already a huge amount of database available, or there is a lot of experience already available. That's where you use CPM. PERT or probabilistic model particularly is used where there is uncertainty, where there's a project which is of new type, or let us say for example, you're designing a building which is going to be the world's tallest building. Now there will be a lot of uncertainties in such projects. Let us say you're constructing the largest airport in the world. So that's a new type of project. There will be a high level of complexity. You're making the world's tallest statue. That's a project in such. So whenever there are new type of projects, research oriented projects, projects with uncertainties, that is where PERT model is ideal, because in such cases, for each activity, it is ideal to consider best case, worst case, most likely case, because if you ask 100 different stakeholders of the project what will be the time required for a given activity or a step, there will be a huge variation. Some people might be optimistic, some might be pessimistic, some might be moderately pessimistic or optimistic. So basically there will be a variation in the data set you collect. So PERT is suitable for such scientific or research oriented projects or large scale projects. That's where you use PERT in project management, and that's where it is ideal to be used. Now in the gate examination, one of the most repeated portion is the relation between these two. So using these 3 time estimate, you calculate something which is called as the expected time, or PERT time or PERT duration you can say, or it is also called as mean duration, or it is also called as expected time. All these are synonyms. The PERT duration, PERT time estimate, or mean duration, expected time, it is generally denoted by TE. Expected time is the term we use. So using these 3 values, you can find out the expected time, and there's a formula for that. You get numericals in the gate exam on that concept directly. Multiple times questions have been asked. Let us try to understand what is the formula for the expected time. TE is given by, can you tell me, if I tell you that all the three are not of same weightage. There is one time estimate which has a higher weightage. Think logically and tell me which one should get a higher weightage when you find out the expected time. Obviously higher weightage should be given for the most likely time. It is not worst case scenario, it is not best case scenario, it is moderate. So the weight, this is also standardized. Now don't ask me how, because I will not go into the basics of the derivation. Mostly, so basically you can remember that the PERT model is based on this principle that you give a higher weightage to most likely time, and the weightage is given as 4. You count this 4 times, whereas you count pessimistic and optimistic time only once. So the average is taken by counting optimistic time 1 time. You consider most likely value 4 times. You consider pessimistic. So basically you're giving a higher weightage to most likely time. You're giving a lower weightage to optimistic and pessimistic time. So to find an average, how much should I divide this by? Sum of the values divided by the number of values. Is the number of values 3 or 6 here? You need to divide it by 6, because you're counting most likely 4 times, not once. If it is counted only once, then you will divide it by 3. Because you're counting, so it's like this: pessimistic time plus most likely time, you count 4 times, and then pessimistic time divided by 6. So this is the formula basically. So this formula you have to remember, and this is asked as a numerical in the exam multiple times for 2 marks directly. You can see, जैसे समझाते हुए मैंने वही तो बोला, the PERT model is based on this concept that you consider it 4 times, and that is given a higher weightage. This is based on the beta distribution. Now I don't want to go into the details of that. That's what I said. It's based. So basically, in simple terms, you can, if I give you a straightforward simple answer, you can say that the PERT model is based on this assumption. As simple as that. So it is standardized. This won't change ever. It is fixed in PERT. Let's look into some numericals on this concept. The first one, this is a 2 marks numerical from GATE 2018. For an activity, the optimistic duration is given as 4, pessimistic duration is given as 11, most likely duration is given as 8, something between 4 and 11. So what is the PERT duration? Can you calculate and tell me for the first question? The PERT duration or expected time will be optimistic time plus the most likely time is counted 4 times, most likely time is 8 days, and pessimistic time is 11 days, divided by 6. What's the answer you're getting? Up to 1 decimal place they are asking, so you can write 7.8 also. But even if you type 7.83, you will not lose your marks. Marks will be given. 7.8 days is the correct answer for the first question. Similarly, the second question which you can see, that is the 2 marks question from GATE 2017. The optimistic, most likely pessimistic time are 12, 15 and 17 months respectively. Calculate the expected time in months. So optimistic time, so expected time is optimistic time estimate of this particular activity or so of this new product is 12 months. 4 into most likely is given as 15 months, pessimistic is given as 17 months, divided by 6. How much is that coming out to be? In PERT there are other formulae also, like you have formula for variance as well. In last 20 years, only once question was asked on it, so I'm not giving you all those details, but you can study about it. In PERT there are other concepts also which you can study. Basically that's what you can remember. So what's the answer coming out to be? 14.8. So this is so in PERT mainly you can remember the most important concept in PERT is this one. The most repeated, you can say, in the GATE exam, the numerical which is most repeated on PERT is this particular formula. There are other formulae also, but if you, I can just write down, I'll not explain it, but you can read about it further. If you want to read about PERT further, you can read about the formula for variance of a PERT activity. Variance of a PERT activity is given by the difference between the pessimistic and optimistic time divided by 6 whole square. This formula is used for calculation of the variance of a PERT activity. For a given activity, if you want to find out its variance is a term which is used in statistics, which is square of the standard deviation basically. So you can remember there was question once in theoretical part asked in the GATE exam. What is variance? It is square of the standard deviation. This is something which you can read about further. So all these are not repetitive. Had it been important, had it been repetitive, I would have explained. In last 30 years, there has been only one question on standard deviation. There has been only one question on calculation of variance. So it's not repetitive. So I have not covered that, but you can study about these to have a holistic understanding of PERT. And as you are, if you have already attended the classes, then for sure we have discussed all these things in detail. And what is the relevance of it? Why do we calculate? We have already studied that. So anyways, you can remember this as the most important point, and this is a quick recall of other important points. Square of the standard, it is denoted by sigma square. Variance is denoted by sigma square. Standard deviation is denoted by sigma. This is the formula for variance of a PERT activity. Uh, anyways, let us look into a question based on network for the network analysis. Uh, I will take up a simple question first, and then we'll solve one question by drawing the network also. I hope we have time. We're short on time, but let us complete. Probably we might need to extend by 5-10 minutes or so. This next question, it is from 2016 paper. A critical path method network for a construction project is given in the figure below. The activity durations are mentioned in weeks. That is clear, I think. Measurement unit is given in weeks. The project completion time in weeks will be dash. So to solve such questions, there are two ways. One, you can do the forward and backward pass calculations. I'm not going to teach you forward backward pass calculation right now in this lecture. I'll tell you an alternative easier method, because in GATE they keep this in mind that the question will be not very lengthy. In smaller questions you can always use this method which I'm going to discuss over here. So basically the first starting node is 1, the ending node is 6. To find out the total duration, project completion time, basically you need to see what are the continuous paths. Listen carefully. If you have no idea on this concept, then you have to listen carefully, because it can be confusing if you're listening it for the first, if you're learning it for the first time. But if you have already studied, then perfectly fine. So you'll understand it quickly. So from starting to ending, if you see in this network, you need to count or write down how many paths are we having. Write down all the paths which are continuous from starting to ending. So from the starting node, for example, I'll write one. ACF is one path. This is called as a path. Can anyone tell me any other path other than ACF? It should be a continuous path from 1 to end, 1 to 6. Other than ACF, I'm talking about this activity A, activity C, activity F. Other than that, ABDF, someone says ABDF nahi hoga. Once you go to A, you cannot come back to this node 3. You have to have these are arrowheads. Look into the arrowheads. You cannot have ABDF. Anything else? BEG. Yes, BEG is one. Tell me the other parts which I have not yet written. So ACF is one, BEG is one. Other than that, look into the arrowheads. B, D, F should be one. What other path are you having? You have one more through the dummy as well. B, E, then the dummy. This is called dummy. I'll write it as x1. They have not dummy activities shown with a dotted line. You can write it as x1, x2, x3. So there's only one dummy. I'll written it as x1. B, E, dummy, and then F. So it is B, D. Dummy you cannot write. You need not write it. Even if you write it, it's not a problem. X1 and F. Other than these four, do you have any other continuous path from 1 to 6? Yes or no? Any other continuous path? Someone was telling BCXG. That is not possible, because the dummy also has an arrowhead. If you see, the dummy's arrowhead is in this direction. You cannot count it in the reverse. The arrow is not here, right? Only these four. There is no more possibility. You need to look into the arrowhead carefully. Now you need to now see what is the length of each path. What is the duration? Someone says one other path. BEX1F. BE. Actually it is BEX1F only, not BDX1F. Correct. Thanks for correcting. After D you don't have X1. It is BEX1F. Correct. These are the four paths. There's no other path. By mistake, I've written it as D. I hope that is clear. It is B, E, X1 and F. Look for the arrowheads. Now, in project management, in a project network, when you have multiple paths connecting starting to ending, so the project duration is calculated like this. You need to see what you need to calculate what is the duration of each path. What is the total duration of ACF? Duration of A plus duration of C plus duration of F. A, C, F duration. Add and tell me. 7 plus 3 plus 4. You are getting 14 days, 14 weeks. This is 14 weeks. Tell me the total duration of BEG. BEG. 6 plus 5 plus 3. 14 weeks again. Tell me for the next one. BDF. 18 weeks. The last one. For dummy, you will take it as 0 days only. This is 0 days. It's not written, right? So this is 0. Dummy has no duration. BEF. 15 weeks. Listen to my question very carefully now. From starting to ending, there are four different paths. One path is taking 14 weeks. One other path is taking 14 weeks. The third path is taking 18 weeks. The last path is taking 15 weeks. If I ask you, what is the minimum time to reach from starting to ending? What is the minimum time to complete the project? What is the minimum time to complete the project? In 14 weeks, this path will be completed. This path also will be completed. But in 14 weeks, this path is not yet complete. This path also is not yet complete. Can you say in this scenario the project is completed? Yes or no? The project is considered to be completed only when all the paths are completed. All the activities should complete 100%. So tell me now, what is the minimum time you have to wait so that all the paths are completed? That will be the answer. That is the project completion time. So this duration is called as the project completion time. So the answer will be 18 weeks for this question. Always remember. So the process goes this way. In any network, if you want to find out the project completion time, you need to list all the paths from starting to ending, continuous paths in the direction of the arrowheads, and see what is the length of each path, and then whichever path is having the longest duration, that is the minimum time you have to wait so that everything is completed. So if you're waiting for 18 weeks, your project will be completed, because within these 18 weeks all the remaining parallel paths will be completed in parallel. So remember, in a project you cannot find the duration by adding the duration of all the activities. That is not how you do, because there are activities which are going on in parallel. To incorporate that, you find out the maximum path length. And remember, does anyone know by any chance what is this path called as? The path which has the longest duration, this BDF, what is that called? Absolutely correct. This is called as the critical path of the network. Critical path is the longest path of the network basically. Critical path can pass through the dummy also if that is the longest path. That is number one. Number two, critical paths can be more than one also. There can be multiple critical paths as well in a network. Uh, is it the maximum time in answer every time? Absolutely yes. The maximum path length, that's not the maximum time. Basically, the project completion time will always be the the path which has the largest duration. That is always taken as the project completion time. Is that clear? Anyone having any doubt? Sure, I can, but let me. I'll do it by the forward and backward pass calculation, but don't expect me to explain it because I don't think that is possible, because it will take, just explaining the intricacies of forward and backward pass itself will take me one complete class. So that's not the idea over here. Uh, but let me explain quickly for if you want to recall. How can path have multiple critical paths? Generally, if there are multiple paths which are longest, then you consider all those paths as critical paths. For example, Just as an example, if I make one change in this question, if say the duration of D is not given as 8, if the duration is given as, let us say, okay, that will not solve the purpose actually. Let us say there is no dummy in this network, and moreover, let us say the duration of activity D that is given instead of 8 as 2 weeks. So if I change the duration, so because there is no dummy, I'm making some changes in the network. If there's no dummy, then this path will not exist. So I'll erase that. If the duration of D is 2 instead of 8, if I change the duration of 8, only one length of the path will change. This will be 14, this will be 14, this will change. How much will this length be? Can anyone tell me? I'm reducing it by 6 days, 6 weeks. So this, instead of 18, it will be 12 weeks. Now tell me which is the longest path in this scenario. Because there is no dummy, there is no other path. Only 3 paths will be there. Which is the longest path here? 14 is the longest one. So this and this both will be called as the critical paths. There can be multiple critical paths in a network. So that's the example in front of you. Is that clear, Janani, for you? Yep. So moving on, Rohan wanted me to show it with the calculation of forward and backward pass. Let me quickly do it. If you have learned already forward and backward pass, you will able to relate to this. I'm doing this calculation because it is given as activity on arrow. I'll just write two values, the early start and late completion values. I'm writing early start values, late completion values at every node, these two values. Starting with 0, the forward pass calculation, here it will be 7 days of early start, here it will be 6, this duration is 6. Then here you have two options, either it will be 7 plus 3 10, or it will be 6 plus 8, which is 14. In the forward pass you always carry the maximum value, so you will write this as 14 here. Actually there's a dummy also, so 6 plus 5 is 11, so you'll have an option of 11 plus 0, that is 11 also, so but it will be 14, which is the maximum value. And then here you have two options, 14 plus 4, that is 18, or 11 plus 3, that is 14. Maximum value is taken into the box 18 here. So this is the forward pass calculation, the duration. Backward pass, you start with 18, and then actually you need not do the backward pass. Once you reach this point, you can write this as the answer directly. I hope you are able to follow, Rohan. So 18 is the answer directly. Without even backward pass, you can answer it. So that's how you solve in the forward and backward pass calculation. The next question, this is from 2024. A network diagram of a construction project is shown in the figure. And if anyone has any question, no? The duration of each activity in days is given, and also the early start time of the project is denoted in the diagram, that is 0. So the project is starting on the 0th day. The total project duration along the critical path will be dash. You can use any of the forward pass method, forward pass, backward pass also you can use, or you can Shailaja, no. There is only one question asked on crashing in last 15 years, so I have not included that into the lecture. I'm just focusing on what is repetitive. So this particular one, let us solve it in the method which we just discussed, listing the paths and identifying the longest path. So from starting till ending, tell me the continuous paths. I'll just help you by writing the first path. One is P, Q, R, V. Tell me the other paths which you have in this network other than PQRV. PSTV. Next, any other paths? PUV, absolutely correct. Any other continuous paths? This is activity on node. Remember the difference. This is activity on arrow diagram. Here the activities are represented on the arrow. Here the activities are represented in the node. This is activity on node. They give you both in the exam. Sometimes activity on arrow, sometimes activity on node. PSUV, PSUV, absolutely correct. P. Any other continuous path from starting to ending from P to V? Everything will start with P, end with V. Only one start and then node. Any other continuous path you have? Look into the diagram and tell me yes or no. Nope. There are no more continuous paths. PSUV is the last one. So what is the path length? Tell me for the first path. PQRV, what is the total duration? 1 plus 9 plus 7 plus 1, 18. Days or weeks, what is it? Days. For the next one, PSTV, 12. What is the path length for PUV? 11 days. What is the last one? PSUV, path length? What do you think is the answer for this question? What is the total project duration? Whichever is the longest path duration, that is taken as the project duration. So the answer for this question also is 18 only. 18 days in integer is the answer for this question. So that is about it. Let us now look into the next one. This will be the last question on network. After this, we will look into float calculation. Someone was telling, if possible, brief on crashing. See, if I just tell you 1 or 2 sentences about crashing, that will not solve the purpose. That is number one. Number two, after this question, the next 10 minutes or so, we can either learn about float calculations or we can learn about the other. I feel this is important because it is most repetitive. So I will prioritize that. So after this question, we'll learn about float. Critical path is always the project duration. Absolutely correct. I'm not sure what your name is, but what you said KAV, that is absolutely right. And in fact, you will get theoretical questions on all these statements. They can ask you project duration is always equal to the length of the critical path. Critical path is always the longest path. There can be more than one critical path in the network. All these statements have been asked as theoretical questions in the past gate exams already. That's the reason I'm trying to incorporate those concepts also when I'm discussing these questions. Let us look into this one. This is a bit complex, slightly difficult because we need to draw the network ourselves. They have not given the network in this question. So let us draw the network based on the information. A construction project consists of 4 activities. A, B, C, D are the names of it. The quantity of work, manpower required, and the productivity of the activities are listed in the table. The interrelationship between the activities is also mentioned in the table. The construction project will start on 29th of January. No holidays for the entire duration. The project will finish on February dash. They're asking us the date of completion. February dash. So for that, first thing you need to draw the network. Second thing, you need to know the project completion time. Then you need to count that number of days from Jan 29th onwards. So let us try to solve this. Firstly, the activities are A, B, C, D, and the immediate successors are given. Duration is not directly given. To calculate the duration, they have given the quantity, manpower, and productivity. Using these three things, you can calculate the duration. We'll do that later. First, based on the activity and immediate successor, let us draw the network. If you don't know how to draw the network, you need to listen carefully, otherwise it can be confusing. If you already have the basics, then you can relate to it very easily. So A, B, C, D are the 4 activities, and the successors, immediate successor as in the next activity is given. So activity A, the immediate successor is C. So I'll be drawing activity on arrow network diagram, or you can also draw activity on node actually. Let me draw activity on node, that will be easier. So activity A, so if you look into the successor column, activity A and activity B are not found here. So A is not a successor to any other activity. B also is not a successor to any other activity. It means activity A and B are going to start from the first node itself. From the starting node, you will get activity A. Let me draw slightly larger so that we can write the duration into this box later. Activity A and activity B, they are not a successor to any other activity. They're starting directly from the starting node. A and B are drawn. Then the activity C is a successor to A. And C is also a successor to B. C is a successor to A also. C is a successor to B also. So activity C will be a successor to A also. It will be a successor to B also. That is given. C is in the successor list for A. C is in the successor list for B. D is a successor only to B. D is a successor only to activity B. Then C has no more successors. D has no more successors. They will end. So they are going to the ending node directly. There is no more successor after this. There is no more activity left after this. This is how the network will be. To find out the durations, Can you people tell me for the activity A, if you want to do 96 cubic meters of work and one person, one person in one day can do 3 cubic meters of work. 3 cubic meter per person per day, per man, per person. And you have 8 workers working on it. So can you first tell me, if one person in one day can do 3 cubic meters of work, the complete project team or this particular activity team of 8 people, how much work can they do in one day? One person is doing 3 cubic meters in one day. 8 people together, how much work can they do? 8 into 3, that is 24 cubic meter of work they can do. If in one day 24 cubic meter of work is done, how many days will it take to complete 96 cubic meters? It will take 4 days. So the activity A has a duration of 4 days. That's how you can calculate. How do you calculate the duration from this information? Basically, duration is calculated by the quantity of work you have. I'll write it in numbers. 96 divided by the number of people in the work team multiplied by the productivity. 8 3 is 24. That's the work done in one day. 96 upon 24 is 4. So the duration of A is 4. Similarly, tell me what is the duration of B? 252 is the total work. 7 people are working at a productivity of 4 cubic meter per person per day. So 252 divided by 7 into 4. How much is that? Duration of B is coming out to be 9 days. Duration of C similarly, the total work is 275 divided by 5 people doing it at a productivity of 5. 275 divided by 5 into 5. 275 upon 25, 11. That's correct. And lastly for D, 126 cubic meter of work, 6 people at a productivity of 3. 6 into 3, 126 upon 18 is 7. This is the network with the durations also. Now list down, how do you find the project completion time? List all the paths. I'll help you by listing one. AC is one path. Tell me the alternative paths from starting to ending. Other than AC you have BC and you have BD. AC, BC and BD. There is no other alternative path in this network. What is the path length for AC? 4 plus 11, that is 15 days. For BC it is 9 plus 7, that is 16 days. And sorry, 9 plus 11 it was, right? 9 plus 11, that is 20 days. And the last one, BD, is 9 plus 7, that is 16 days. What is the project completion time? Largest, longest path will give you the project completion time. So 20 days is the project complete. 20 days is the project duration. Count 20 days from January. January 29th also is a working day. Project is starting on that. Jan 29, Jan 30, Jan 31. There are no holidays in between. 3 days in the month of January. How many days you have to work in February? If you're working 3 days in January, total 20 days is the duration. How many days you have to work in February? 17 days you have to work in February. So the project will be completed on the end of the day of 17th February. So the project completion date will be 17th Feb. On the evening of 17th Feb, after completing your work, project is finished. So that's the meaning of this. So 17 is the answer. So they can sometimes they can ask you directly duration. Sometimes they can give you date and ask you. So you need to count the number of days in that case. So that's about it. The last concept under project management is to understand about float calculations. I'll just give you the formula for these 4 types of float like I told you in the beginning. I'm not going to give you the definitions and the details. Ideally, you should learn that, the definitions and the meaning exactly, what is the underlying rule. That is something you can remember. Sure, Harshank, I can. You did understand that 20 days is the project time. So you have to count 20 working days from January 29th. So basically January 20, in the month of January, you're working for 29th, 30th and 31st. 3 days in the month of January, and you need to work for 17 days in the month of February also. So in the month of February, if you're working for 17 days, on the February 17th, because they said there are no holidays, February 17th will be the finished date. So because you need to work for 17 days in February. Is that clear, Harshank? Because of the start date of Jan 29th, you get the answer as Feb 17th. Let us look into the float calculations like I was telling you. There are four types of float, starting with the first one, total float. Always remember, how do we, you need to count 29th also, Rajeshri. 18th Feb cannot be the answer. So this is working day. It is starting on 29th morning and your project will be finished on January 17th at the end of the day. So 17th only is considered. You are working on February 17th also. Is that clear, Rajeshri? Okay. I was telling you about the float calculations. Listen carefully. The total float is always calculated this way. If you're having an activity with a known duration, I'm writing duration as DUR in short. Each activity will have four values. In forward and backward pass calculation, you calculate four values for each activity. And those four values are early start time of the activity, early finish time of the activity, late start time of the activity, and late finish time of the activity. Each activity has four values: early start time, early finish time, late start time, and late finish time. Now these four values, how do we calculate? That depends on the forward and backward pass calculation. But generally in the examination, when you have these float based calculations, they will give you the values themselves. If they don't give by chance, you need to know the calculation part, which basically I quickly gave you one example how we did the forward pass. That's how you get these values actually. But generally they'll give you the values in the float calculation in the examination. But ideally you should learn that too. So total float for an activity, when these four values are known, it is given by this formula. Total float is equal to the late start time minus the early start time. Or you can also use, this is one formula. One more formula you can use is the late finish time minus the early finish time. Both the formula will give you the exact same answer. You can use any of these two formulae, both will work fine. In the GATE exam, sometimes there have been questions where they directly ask you the formula also. Such questions have in theoretical part. For 1 mark, such questions have been asked in the past as well. That is total float. Uh, the ideal derivation of it actually comes from this. You can also calculate it like this: LFT minus EST minus duration. So that's how you actually get it. But then let me not derive it. You can remember these two formulae. Number two, free float. Free float of an activity. To calculate the free float of an activity, you need to know the information of its successors also. So let us say you have an activity with a known duration and it has a successor. Successor is next activity. There can be one successor, there can be more than one successors also. If you're having a successor, that successor also has some duration and you'll have four values. I told you already. Even the successor will have those four values. You'll have early start time, early finish time, late start time, late finish time. Even the successor will have four values: early start time, early finish time, late start time, and late finish time. These four values you will have it in the successors also. Difference between late start time and early start time. Late start time and early start time basically, uh, now what you asked has a very long answer, but in short, I can tell you the meaning of it. Early start time tells you the earliest time when this activity can start, the earliest possible time. So after the start of the project, after how many days can you start this activity? Late start time on the other hand is the most delayed time without delaying the project completion time. What is the maximum time you can wait and start this activity? That is the late start time, the late most start time. Now this is a very basic thing. As I told you, you should know the forward and backward pass calculation, which is not a scope of this revision class. We are just looking into the application part. We are not for, it's not possible for me to teach the foundations as you are aware of it. I told you in the beginning itself, right? So that's the scenario. So every activity and also the successor will have all these values. You can calculate free float by using this particular formula. Free float is given by the minimum early start time of all the successors. Here there is only one successor, so you can take the early start time of it directly. But if there are multiple successors, you have to see what is the minimum early start time of all the successors. If there are three successors, compare the early start time of all the three successors and see whichever is minimum. So you can write the formula like this: minimum early start time of the successors, the minimum early start time of all the successors. If there are multiple, so if there's only one successor, you can directly take the EST of the successor, early start time of the successor, minus the early finish time of the given activity, minus early finish time of activity, as in that activity for which you're calculating float. जिस activity का float calculate करा जा रहा है, so whichever activities float you're calculating, you take the EFT of that activity. In the diagram it will look like this: the minimum EST of the successors minus the early finish time of this activity. In the previous one, total float, it is LST minus EST, or LFT minus EFT. Both will give you the same answer. In free float, you take the minimum early start time by comparing all the successors. If there is one successor, you will take its EST minus EFT of the given activity. That is the second formula. Questions are asked on all these formulae in the gate examination. The third one is interfering float, which is actually straightforward. If they ask you interfering float, it is directly total float minus free float. This is called as interfering float. By definition, interfering float is the difference between total float and free float. So you can use the formula of total float, you can use the formula of free float, which we discussed earlier, and find the difference. That will give you interfering float. The last one is independent float. First, write down these points into your notes. I know it can sound, if you don't know the basics of float, the definitions, it can sound very overwhelming and confusing. Write down the definitions, spend some time on it. It will be clear for you, and then practice questions. That should be enough. But I personally recommend you to know the basics. You should know the definitions. You should know the relation. You need to know what is EST, what is EFT, what is the meaning of total float, free float. Those basics are important too for getting a holistic understanding. So independent float in any ways. So let me write down in the form of a network. Let us say, for example, for calculation of interfering float, you need to know the values for predecessor and successor both actually. So if there is an activity with some known duration, let us say this is the successor of that. Successor has some duration, and there is a predecessor also to this activity. Predecessor is previous. The predecessor activity also has some duration. All these three activities will have EST, EFT, LST, LFT, EST. Right? So you'll have early start time, early finish time, late start time, and late finish time. Similarly, this activity also has EST, EFT, LST, LFT. Early start time, early finish time, late start time, late finish time. Right? Now in this diagram, independent float of the activity, we are calculating independent float of this activity, not the predecessor or the successor. Independent float is calculated using this formula. Independent float is given by the minimum early start time of all the successors. If there is one successor, you will directly take the EST of it. If there are multiple successors, you will compare and take the minimum value. It is minimum early start time of the successors. This minimum will be applicable only if there are multiple successors. If there is one successor, no need of minimum. You can directly take, there will be only one option. There is no comparison to select minimum. So minimum EST of the successors minus the maximum LFT of the predecessors. Now, you should I can tell you these formulae whenever you ask me, not because I have by hearted. I don't know so I have not by hearted based on this statement. So I know the basic formula. That's how I remember this. So understand the basic definition. That is always ideal way to remember these formulae. So minimum early start time of the successors minus the maximum late finish time of all the predecessors. If there's one predecessor, you will directly take the LFT of it. But if there are multiple predecessors behind this activity, you need to compare and take the maximum value minus maximum LFT of the predecessors. Minimum EST of the successors minus maximum LFT of the predecessors minus the duration of the given activity. Minus duration of the activity. Activity here is that activity for which you're calculating the independent float. This is the formula for independent float of the activity ACT, whichever I have determined. Let me mark it in the diagram. You can remember these formulae in the form of diagram also, that will be easier. So it is EST of the successor minus LFT of the predecessor. This minus LFT minus duration of the given activity. That is independent float. Let me very quickly recall these basics, and we'll solve the questions after that. So if you look into this first one, in total float, you need not know any information of predecessor successor here. It is just LST minus EST. That's it. The late start time minus early start. LFT minus EFT. That's it. For free float, you need to know the successor's information. It is EST of the successor minus EFT of the given activity. Interfering float is total float minus free float. Lastly, for independent float, you need to know the information of predecessor and successor both. It is EST of the successor minus LFT of the predecessor minus duration of the activity. Let us look into some example, questions from GATE exam which have been asked in this context, to know how to solve what type of questions have been asked in the past. This is a 2 marks question, 2 marks numerical from GATE 2022. The activity duration, early start, early finish, late start, late finish in weeks are given in this for PQRS in the figure. The interfering float of R is dash in weeks. Interfering float is being asked. By definition, what is interfering float? Interfering float of R is equal to total float minus free float. Total float of R minus free float of R. So total float minus free float, that will give you the interfering float. What is the total float of R? I told you total float is value at the bottom minus value at the top. You can do that on the other side also. You can do 27 minus 15. You will get the same answer. If you use 24 minus 12, you are getting 12. 27 minus 15 also will give you 12. You will always get the same answer. That's the condition actually for any activity. So total float of R is 24 minus 12. That is total float of R, which is coming out to be 12 weeks. What is the free float of R? Can anyone tell me what is the free float of R? Free float is calculated as the minimum early start time of the successors. There's only one successor, so directly 21 minus early finish time. This will be 21 minus 15, which is 6 weeks. What is the final answer? Total float is 12 weeks, free float is 6 weeks, interfering float will be 12 minus 6, that is 6 weeks. The answer for this question is 6. In weeks, the answer is 6. So if you know the formula, if you know the concept, it is hardly 10 seconds to solve this question and you can score 2 marks easily. If you don't know the formula, you lose those 2 marks. So remember whatever four formulae I have given you, remember those formulae. To remember that, understand, you can do your self study once if you are not clear on it, read the definitions and then remember the formulae. Errors in the network diagram as in Shreya, what do you mean by errors in the network diagram? In this, are you asking about this particular network? Nope, I don't think there have never been questions in the last 20 years, not 20, even 30. So I'm not going to cover that as such in this class, right? Let us focus on, in the GATE exam, there have never been questions on that. This last question, it is from GATE 2020. The activity duration I thought you are asking because this question, this particular network has some errors actually. Reason being, this is not the holistic network. There are other activities also. They gave a part of that. That's the reason. In any case, let us look at this last question. The activity duration, early start, early finish, late start, and late finish of activities P, Q, and R are shown in the network. Independent float of activity Q is being asked. You know the formula for independent float? Independent float of Q is equal to, it is the minimum early start time of the successors. There is only one successor, so directly 22. All these are given in, they have not mentioned any measurement units, days, weeks, irrespective. They are just given numbers. You need just to solve it. Just need to solve it using that. Minimum early start time of the successors minus maximum late finish time of the predecessors. There's only one predecessor, so directly 15. From this, you subtract the duration of the given activity. This minus duration of the activity. So 12, so 22 minus 15, that will be 7 minus 6. The answer is 1. The independent float for this is, that's the answer for this question. I hope the basics are clear for you. In addition to what we have studied, if you don't know how to draw the network, I think you should prioritize on that. Your priority should be to understand how to draw the network, how to do the forward and backward pass calculation, and how to find these numbers. That is an additional part which you can do from your end if you don't know that. If you know that already, that's well and good. So this is a basic of the important parts of project management. So I think we can uh, actually, that's a very lengthy concept. I cannot explain it in 5 or 10 or 15 minutes also. It will take more time than that. So I think it will just create confusion even if I try to do that. So I think you can study that from your end, crashing. That said, only one question has been asked till date in last 15 years. So someone was asking about the voids part. I can just give you a hint on that. So basically here in this question, if you want to subtract the voids, you can find out the total volume of the slab from top to bottom, everything. This complete solid slab, you can find out the volume first. And then there are 1, 2, 3, 4, 5, 6, 7, 8, 9 depressions. So these 9 voids you need to find, these cutouts you need to find the dimension of it and subtract it. Each of it is a cuboid, so it is length into breadth into height. The depth of each of this void will be 45 centimeters, so 0.45. You can see that in this diagram also. Other than that, you can look into the diagram. The total is 10. You need to divide it equally into 3 parts and find out what this dimension is. So this and this will be same. It is a square. So this length into 0.45. That is volume of each void. That multiplied by 9 will give you 9 voids. Those 9 voids volume you need to subtract from the overall outer slab volume. That's the approach basically. You can practice, I told you, this particular uh, approach too. The class recording available after the class? Yes, Miramad, the recording of this session will be available on your app in your course. Yeah, no worries. You can watch whatever part you're missing. Because it's a lengthy lecture, it's already more than 3.5 hours. It will take time for it to basically get downloaded and uploaded. So we'll try our best to get it uploaded at the earliest, but I think it will be uploaded before tomorrow. So before tomorrow's class, you should get the recording of today's class. So it can take some time, but we'll try to do it at the earliest. Independent float. I can show you the formula, sure. That's the formula for independent float. Let me know when you're done, Harshank, and also we, both of you. Please say important topic for this remaining 9 days. Uh, so we've already shortlisted the important topics and we are taking the revision classes for it. What you can do is, you can, if you are working already, you can just focus on the lectures, the revision which we are doing, but in the form of recordings. If you're not able to attend some lecture on live, you can do on Acha, you want to take week off? Okay, let me open the schedule and we'll share that. Let me share my thoughts on the important topics here. I for sure think today's lecture is an important topic. So we've scheduled it already on day one. Housing and environment. So I personally feel you can prioritize those subjects which are in the common part because that's where you have the maximum weightage. Housing and environment also are common part subjects, so that is also important. Lighting and acoustics is something which comes under the architecture part. Weightage is a bit lower because architecture part together will have only 25 marks of weightage. That said, lighting and acoustics will have a weightage of 2 to 3 marks. So if you are planning to attempt B1, that is architecture, then this lecture is important for you if you are attending. Similarly, climatology and acoustics also are predominantly common into B1 part. Some basics of climatology are in the common part as well, but still you can prioritize this subject in general if you are focusing on B1, that is architecture part. Landscape and urban design is in the common part, so this is important. But if you, because landscape and urban design are more of theoretical ones, in landscape you have runoff calculation, that's one thing. In urban design there is no major numerical part. You do have the enclosure and the experience of enclosure. There are some calculations related to that, uh, loss of enclosure and all, but that's not very frequently asked. In landscape there is runoff, so this runoff topic if you know already, then you can have secondary. You can, do not recommend you to miss any lecture, but live classes you can skip if you want. These things, this you can skip if you don't, if you are attending planning part, right? So landscape and urban design, like I said, it is more of theoretical. If you know it already, you can skip, otherwise it is important. Then PTM and transportation, if you are opting for B2, that is planning part, then you should attend this lecture. If you are attending architecture part, then you can skip this. So that's how you can actually prioritize maybe. History and valuation. So in this lecture, we will limit ourselves for history. We'll focus mainly on valuation. So I personally think you should attend valuation because you'll get numericals from this in the common part. So valuation is an important one. But you can rely on recorded class also. That is fine. Urban planning too is important, but I think this lecture will not be very long. It will not go more than 3 hours. So you can attend this lecture easily. Structures and fire safety, not huge weightage. Structures is only for architecture part people. Fire safety is in the common part, but I think it is easy to cover even through recording. The last one too, water supply, sewage treatment, and this is important. It is in the common part. I hope that gives you a bit of idea. So you can think yourself which are your strong areas. Think yourself which part are you prioritizing. Accordingly, you can make a plan for your self study. I think you got your answer. 1 plus. Yep. Uh, I you want to Samta has a question. B1 and proceed if you're attending P2, is it mandatory? Samta, so at this point of time, only one IIT has such rule, IIT Kharagpur, that too for MARC. If you want to pursue sustainable built environment MARC course at IIT Kharagpur, it is mandatory for you to select B1 part. By selecting B2, you cannot take admission there. Other than that, you can select B1 or B2 and get into any other college. There is no rule in M-Plan of Kharagpur and M-Plan of IIT Roorkee or any other NIT or SPA. There's no rule for M-Plan. You can select B1 and do M-Plan, but you cannot select B2 and do MArch at IIT Kharagpur. That's the only exception at this point of time, at least. Uh, Salja, mini mocks actually are a mock of all the subjects together. I don't think there are for subject-wise practice. We'll upload these practice sheets. So there are some homework questions we skip through. That is something you can practice actually. But I don't think in test series you will have a separate set of tests in this course added. So I think I've answered all your questions. So that is all for today. Thank you all for attending the lecture. We'll meet day after tomorrow is not my class. So we'll meet on 28th when my next lecture is scheduled. That is for lighting and acoustics. Bye all of you.
KP classes dedicated to excellence.